Just yesterday, the well-known podcaster Joe Rogan featured an interview with Avi Loeb, and the timing of this release couldn't be more opportune. Today marks a significant astronomical event. The celestial body known as 3 Atlas is currently making its closest approach to the Sun, an occurrence called perihelion, the very moment we've all been anticipating. Within that extensive conversation, nestled between discussions concerning the Fermi Paradox and the literary works of Arthur C. Clarke, Avi shared insights about 3 Atlas that many listeners might have overlooked. These are details that truly illuminate the extraordinary nature of this object. If you pay close attention to his statements regarding the anti-tail phenomenon, the nickel emissions, and its almost perfectly spherical form, you begin to understand that the scientific community has been grappling with something genuinely anomalous for months. Something that stubbornly resists integration into our established models and challenges our fundamental assumptions about what objects originating from beyond our solar system ought to resemble. If you find value in this in-depth analysis, please consider showing your appreciation by gently tapping the like button and subscribing to ensure you stay updated on further developments. I'd also love to hear from you in the comments. Where are you tuning in from? What time is it where you are? And what do you consider to be the most compelling anomaly presented by 3i Atlas? To help our community grow, please share this content on your social media platforms and don't forget to hit that new hype button. Your support is greatly appreciated. Let's rewind the clock to July and August of this year, a period when astronomers worldwide were intently observing 3i Atlas as it journeyed towards our solar system. They meticulously captured images, conducted spectroscopic analyses, and performed all the rigorous scientific procedures expected when a substantial object from outside our solar system enters our cosmic vicinity. It was during this period that they observed something truly unprecedented, something that defied conventional understanding, something that seemed to contravene the basic principles of physics as we currently comprehend them. 3 Atlas possessed an anti-tail. Now, before you dismiss this as mere technical jargon, allow me to explain why this observation is profoundly perplexing. When any comet ventures close to the Sun, it begins to heat up. Its ice vaporizes into gas, and dust particles are released. Here's the crucial part. These dust particles, typically around half a micrometer in diameter, roughly the wavelength of visible light, are incredibly effective at scattering sunlight. The Sun, you see, is not merely a stationary ball of light. It acts as a cosmic wind machine, constantly exerting an outward force through radiation pressure. When these dust particles are struck by sunlight, they are propelled away from the Sun, always in an outward direction. This isn't a theoretical concept, it's a scientifically observed fact. Every single comet we have ever studied, numbering in the hundreds, exhibits this precise behavior. The dust invariably trails behind the comet, moving away from the Sun, thus creating the iconic tail that is universally associated with these celestial bodies. However, 3i Atlas behaved in the complete opposite manner. Throughout July and August, as it approached the Sun, material was observed to be flowing towards the Sun, not away from it. Imagine watching a video of a waterfall flowing upward or witnessing smoke drift downwards instead of rising. It's the sort of phenomenon that makes you doubt your own observations, question the accuracy of image processing, or even suspect a malfunction in your telescope. But the instruments were functioning correctly. Multiple observatories corroborated the findings. The anti-tail was undeniably real. Avi did not sensationalize this discovery. He presented it as a straightforward fact, almost casually delivered. Yet, if you listened intently, you could discern a subtle undertone in his voice, hinting at the profound implications that clearly occupied his thoughts. When Joe Rogan directly questioned him about this, pressing him on whether it could be a natural occurrence, Avi deviated from the typical scientific hedging. He didn't resort to phrases like, "We need more data." Instead, he acknowledged, "This is very unusual." Consider the implications for a moment. Picture yourself driving on a highway and witnessing a car traveling backward at 70 miles per hour. Not merely rolling backward, but actively accelerating in reverse, engine running, moving against the flow of traffic. Your immediate thought wouldn't be about a faulty transmission. Your first conclusion would be that something fundamentally different is happening. Either the driver is intentionally performing this maneuver, or the laws of physics in that specific location have somehow been altered. There is no middle ground. The anti-tail of 3I Atlas represents precisely that scenario. Now, the prevailing explanation, the one that allows scientists to maintain a sense of normalcy, suggests that perhaps there's a geometrical quirk at play. Perhaps we're observing the object from an unusual angle, or it's an optical illusion. It might be that the dust is being released in intermittent bursts, leading to a complex interaction between different particle sizes, radiation pressure, and orbital mechanics. And, of course, it's possible. However, Avi highlighted a critical point that causes this conventional explanation to falter under scrutiny. If this were solely a matter of geometry or viewing angle, we would have encountered this phenomenon countless times before. We have observed hundreds of comets from every conceivable perspective. We have dispatched spacecraft to study comets up close. In none of those instances, not a single one, have we ever witnessed an anti-tail that persisted for months. But the strangeness doesn't end there. In September, a significant change occurred. The anti-tail vanished, or, more accurately, it reversed. 3I Atlas abruptly began behaving as expected, developing a conventional tail that pointed away from the sun, as a typical comet would. However, as Avi emphasized during the interview, even this seemingly normal tail is peculiar. It is exceptionally small, significantly smaller than anticipated. Other comets at comparable distances from the Sun, exhibiting similar brightness, display massive tails that stretch for millions of kilometers. 3 Atlas, by contrast, possesses a barely discernible tail. So, let me clarify. For 2 months, we observed impossible behavior, and then, suddenly, normal behavior, albeit not entirely normal. This is not how the natural world operates. Nature is characterized by consistency. The laws of physics are consistent. If you are simply a chunk of ice and rock hurtling through space, you don't get to arbitrarily choose when to adhere to the laws of physics and when to disregard them. Unless, of course, you are not merely a chunk of ice and rock. Joe Rogan, to his credit, identified this inconsistency and pressed the issue. He suggested, perhaps this is simply a natural phenomenon. Maybe our understanding of comets is not as complete as we believe. Avi's response was fascinating. He didn't dispute this possibility. He stated, yes, it could be natural. We need to ascertain the reasons for its unusual behavior. He then transitioned to a point that I believe most listeners of that podcast missed. He spoke about how we have documented hundreds of comets, but have only confirmed the existence of 2 interstellar objects, Oumuamua and Borisov. With the inclusion of 3 Atlas, that brings our total to 3. This gives us only 3 data points for objects originating from outside our solar system. Notably, 2 of these, Oumuamua and 3I Atlas, exhibit wildly anomalous characteristics. Oumuamua displayed unusual acceleration without visible outgassing, possessed a bizarrely elongated shape, and exhibited erratic tumbling motion. Now, 3 Atlas presents its own set of anomalies. The anti-tail, the nickel emissions, and its near-spherical form. Only Borisov appeared to conform to conventional expectations. That's 1 out of 3 exhibiting standard behavior. If I were to tell you that 1 in every 3 cars you encounter on the highway was driving backward, would you conclude that our understanding of automobiles is flawed? Or would you infer that something distinctly different is happening with those particular vehicles? The enigma of the anti-tail is not solely about dust particles moving in an unexpected direction. It's about the profound implications of such a phenomenon. There are, in essence, only a few plausible explanations, and none of them are particularly comforting. The first possibility is that our comprehension of radiation pressure and cometary behavior is fundamentally erroneous. This would imply that decades of planetary science, supported by thousands of observations, have somehow overlooked a basic principle, a highly improbable scenario. The second possibility is that 3 Atlas possesses an exotic composition unlike anything we have encountered before, interacting with sunlight in entirely novel ways. While conceivable, this leads to the question of why interstellar objects would possess such unusual compositions. What are they made of that our local comets are not? The third possibility, the one that Avi delicately alludes to without explicitly stating, is that the observed behavior is not passive, but active. This would involve intentional outgassing, deliberate maneuvering, or some form of active control. I am not suggesting that 3I Atlas is a spacecraft. However, the data, the actual observations, including the anti-tail that persisted for 2 months before vanishing, are more consistent with active processes than passive ones. This realization should evoke a mixture of concern and excitement. Avi mentioned during the interview that we do not possess a high-resolution image of 3I Atlas. We cannot discern its actual physical structure. All we have is the light it reflects, and from that we infer its properties over time. Yet, even without direct visual confirmation, its light curve reveals something profound. We know, through measurement, that 3 Atlas completes a rotation every 16 hours. If it were shaped like a typical comet, elongated, irregular, perhaps potato-like, we would expect to see significant fluctuations in its brightness as different surface areas faced us. However, this is not what we observe. The brightness remains remarkably consistent throughout its rotation, indicating, crucially, that 3I Atlas is nearly spherical. Not perfectly so, there are minor variations, but it is close enough that its rotation has a negligible effect on the reflected light. Comets are not spheres. Asteroids are not spheres. Smaller celestial bodies are generally irregular in shape due to impacts and chaotic tumbling. The only objects in space that naturally achieve a spherical form are those massive enough for their own gravity to pull them into that shape. While 3I Atlas is substantial, described as Manhattan-sized, it is not nearly massive enough to be naturally spherical. This spherical shape strongly suggests it was manufactured that way. I've stated it now, the notion that many are contemplating but few scientists dare to voice. What if 32nd Atlas was intentionally designed? What if its anti-tail was not a defiance of physics, but rather an indication of a propulsion system beyond our current understanding? What if the transition from an anti-tail to a conventional tail in September was not a natural event, but a deliberate change in operational mode? Avi did not articulate these possibilities directly in the interview. He is far too precise for that. However, he presented all the necessary evidence, providing the data and highlighting the anomalies. He then shared a perspective that I believe is fundamental to grasping his entire approach to this subject. He referenced Pascal's wager. Blaise Pascal, the 17th-century mathematician and philosopher, proposed an argument concerning the existence of God. He posited that while the probability of God's existence might be small, the potential implications of his existence are so immense, even infinite, that we must seriously consider the possibility and act as though it were true. The cost of being wrong, of dismissing it and then discovering its reality, is, in his view, infinite. Avi applies a similar logic to 3I Atlas. Perhaps it is merely a celestial rock, a peculiar comet with an unusual composition and unconventional outgassing patterns. The probability of it being alien technology might be low, but the implications are so profound that we must investigate it with utmost seriousness, gathering every available piece of data and refraining from dismissing anomalies simply because they make us uncomfortable. This is where the interview takes a particularly intriguing turn as Avi begins to discuss intelligence agencies. He draws a parallel to the events of October 7th, specifically referencing the intelligence failure in Israel. He points out that a prevailing theory suggested Hamas would take no action, despite data indicating otherwise, and how this contradictory data was dismissed because it conflicted with the established theory, ultimately leading to catastrophic consequences. The parallel is striking. The scientific community operates with a prevailing theory. Interstellar objects are natural phenomena, comprising rocks and comets. Any data that contradicts this theory is often dismissed, not necessarily because the data is flawed, but because it challenges a deeply entrenched belief. Avi is essentially asking, consider the outcome when such dismissals occur in high-stakes situations. Lives are lost, civilizations decline. Are we potentially making a similar error with 3ATS? Today, October 29th, marks the perihelion of 3I Atlas, its closest approach to the Sun. Whatever significant events or data are to emerge, they are unfolding at this very moment. The mystery of the anti-tail, the seemingly impossible physics of material flowing toward the Sun for 2 months, remains unresolved and unexplained. As we observe this object making its closest pass, with telescopes across the globe focused on this Manhattan-sized visitor from interstellar space, we are compelled to ask a fundamental question. Are we witnessing a comet, or something far more significant masquerading as one? The anti-tail phenomenon itself is indifferent to our beliefs. It undeniably existed, was confirmed by multiple observatories, and then ceased. This cessation was not gradual, nor did it involve a smooth transition indicative of natural processes. It simply stopped. And according to Avi, this abrupt cessation is precisely what troubles him the most, more than anything else he discussed during that 3-hour interview. The reason is simple. Nature does not possess an on-off switch, but technology does. The cosmic conspiracy unfolds. When scientists attempted to suppress the truth, the moment Avi began questioning the water content of 3ATLAS, the attacks commenced. These were not subtle disagreements or polite academic debates. They were outright assaults. What transpired next reveals a darker aspect of how scientific inquiry can operate when the stakes become sufficiently high, when the implications prove too unsettling, and when the data threatens to dismantle decades of carefully constructed narratives. Joe Rogan brought this subject up early in their discussion, and Avi's response was remarkably telling. He mentioned, almost in passing, that some individuals had accused him of fabricating the existence of 3 Atlas as a means to divert attention from the Epstein files. Let that sink in for a moment. A Harvard professor, one of the most distinguished astrophysicists of our era, was accused of fabricating a Manhattan-sized object in space, visible to anyone with a telescope, for the sole purpose of creating a media distraction. The sheer absurdity of this claim is breathtaking, yet it perfectly illustrates the desperation of his critics. When the data cannot be challenged, the person is attacked. When the observations cannot be refuted, their motives are questioned. This is not the practice of science, it is political maneuvering. And this has been a recurring pattern for Avi for years, ever since he first dared to suggest that Oumuamua might possess an artificial origin. However, the controversy surrounding the water content is where things become truly illuminating. This is not a matter of speculation. It is based on concrete data. Several research teams hastily published papers claiming to have detected significant quantities of water within 3 ATLAS. Press releases were issued, and headlines proclaimed that the enigmatic comet was merely an ordinary icy visitor. The matter, they suggested, was settled. Everyone could return to their previous assumptions, except Avi meticulously examined their papers. He delved into the actual data and concluded, no, this is incorrect. One team's findings were characterized by error margins so vast that their detection was effectively rendered meaningless. Imagine being told that the height of a building was measured as 100 feet plus or minus 200 feet. Such a measurement provides no useful information. It's essentially noise masquerading as data. Yet, they proceeded to publish it, secured their press release, and enjoyed their fleeting moment of notoriety. When Avi pointed out the inadequacy of their data quality, he was subjected to criticism for being overly demanding, for being a contrarian, and for upholding impossibly high standards. Another research group adopted a different methodology. They made certain assumptions, postulating a specific amount of dust obstructing ultraviolet light. Based on these assumptions, they extrapolated backward to estimate water content, arriving at a substantial figure sufficient to declare, "See, it's just a comet. Nothing unusual here." However, the fundamental flaw with assumptions is that if the initial assumption is incorrect, all subsequent deductions will also be erroneous. Avi stated, "I do not believe your assumption is accurate. Where is the evidence for this assumed dust?" The scientific community did not respond favorably to this line of questioning. Avi mentioned during the interview that he faced backlash for his skepticism not from the general public or conspiracy theorists, but from his fellow scientists, his peers, individuals who should have upheld the principles of skepticism and rigorous analysis. They criticized him for performing the very actions that scientists are expected to undertake, questioning assumptions, demanding evidence, and refusing to accept conclusions that contradict the data. Then came the observation from the Webb Telescope. The James Webb Space Telescope, the most advanced infrared observatory ever constructed, focused its instruments on this mysterious visitor, directly measuring its composition. No assumptions were involved, no error margins overshadowed the actual measurement. It was a direct spectroscopic analysis. And what did the Webb telescope reveal? It detected 4% water by mass. 4%. Not the substantial water content claimed by the other teams, and certainly not enough to account for the observed activity through simple ice sublimation. 4%. Avi was correct. The teams that rushed to publish their findings were mistaken. The press releases were inaccurate, the headlines were misleading. More importantly, the narrative they were attempting to construct, the comfortable story that 3I Atlas is simply a run-of-the-mill comet, had crumbled. But here's what is truly unsettling. When the Webb Telescope released those findings, vindicating Avi's skepticism, did those teams issue corrections? Did they acknowledge their errors? Did the journals that published their papers issue retractions? Silence. The scientific community simply moved on, as if the entire embarrassing episode had never occurred, and Avi, the individual who was attacked for being right, continues to be perceived as an outsider, a troublemaker, the one who poses uncomfortable questions. This is not how scientific progress is supposed to function. Science should be a self-correcting mechanism. When new data contradicts existing conclusions, those conclusions should be updated. Errors should be admitted, and lessons should be learned. However, When an error threatens a deeply held belief, when admitting fault opens the door to possibilities deemed frightening, the rules inexplicably change. In such instances, maintaining consensus becomes more important than adhering to the data. The finding of 4% water content is devastating to the hypothesis that 3I Atlas is a conventional comet. If 3I Atlas contains only 4% water, what constitutes the remaining 96%? Rock, metal, or something else entirely? Crucially, if it is composed primarily of non-water materials, how is it generating any outgassing at all? Water ice is the primary driver of cometary activity. This is fundamental knowledge. Heat ice, it turns to gas, gas expands, creates pressure, expels dust, forming the coma and tail. This is the established mechanism. However, with only 4% water, the observed level of activity cannot be explained. The mathematical models do not align unless an alternative factor is driving the outgassing, unless a different mechanism is at play that we do not yet understand, or unless the activity is not passive sublimation, but active expulsion. Avi did not explicitly state this in the interview, but the implication is palpable. I believe this is precisely why the scientific community reacted so fiercely to his skepticism regarding the water claims. If those claims had been accurate, and 3I Atlas were indeed rich in water ice, then everything could have been explained within a conventional framework, albeit with some unusual characteristics. But if the water content is indeed low, as indicated by the Webb Telescope and contradicting the earlier rushed publications, then we are venturing into uncharted territory. This necessitates considering explanations that provoke significant discomfort. Joe Rogan pressed Avi on this very point during the interview, asking, "Could this still be a natural phenomenon? Is there an explanation we're overlooking?" Avi's response was perfect. He replied, "Yes, it could be natural. We need to determine why it is so unusual." He emphasized, not, "We need to prove it is alien," not, "We need to defend our theory." We need to figure out why it is unusual. This is the true scientific approach. Start with the anomalies, investigate them with honesty, and follow wherever the data leads. However, this was not the approach taken during the water content controversy. The opposite occurred. The conclusion was predetermined. Comet equals normal. Then, efforts were made to find data that supported this conclusion while disregarding any data that contradicted it. Only text, no instructions or comments. Confront anyone who challenges your approach. Uphold the established narrative above all else. However, there's an additional dimension to this enigma, which Avi alluded to when discussing the visibility of Object 38. He noted that one could purchase a telescope with a diameter of 1/2 meter through online retailers and observe it from any location on the planet. It is not concealed. It is not a secret. Any individual possessing basic observational apparatus can witness this celestial body and confirm the gathered information. This reality renders the assertion that he fabricated it utterly preposterous. Nevertheless, it also amplifies the disquieting nature of the scientific community's reluctance to engage in thorough investigation. Had this been a faint, distant entity observable only by a select few observatories, a degree of hesitation might be understandable. Perhaps the data was ambiguous, or superior instrumentation was required. Yet, the object designated 3I Atlas is luminous and accessible. We possess the capacity to scrutinize it in detail, providing definitive answers to these inquiries. The sole impediment is a lack of resolve, or more accurately, an apprehension concerning what discoveries we might unearth. Avi highlighted that no governmental financial support has been earmarked for the pursuit of extraterrestrial technological indicators in space. In stark contrast, over 10 billion units of currency are being expended on the search for microbial life signatures on exoplanets. Contemplate this disparity. 10 billion directed towards the search for microscopic organisms versus zero allocated for the search for advanced technology. This occurs despite the fact that technology would be considerably simpler to detect. The ramifications of discovering advanced civilizations would be far more profound, and we possess undeniable certainty that technological societies exist. We ourselves are one. While the existence of microbial life elsewhere remains uncertain, this allocation of resources is not a scientific determination, it is an ideological stance. The scientific establishment has consciously or unconsciously decreed that the investigation into alien technology is not a reputable endeavor. Such pursuits are relegated to eccentrics and proponents of conspiracy theories. True scientists, in their view, focus on microbes and analyze exoplanetary atmospheres for elements like oxygen and methane. They do not squander time on fanciful notions of extraterrestrial beings. However, Avi Loeb is a genuine scientist, acclaimed as one of the most frequently cited astrophysicists currently active, and formerly held the position of department chair for astronomy at Harvard. He is hardly an obscure figure. His assertion is straightforward. Observe this object. Examine the data. Something extraordinary is unfolding. Instead of initiating an investigation or allocating resources for enhanced observation, the response has been to sideline him, undermine his credibility, and accuse him of seeking attention or fabricating conspiracies. The controversy surrounding the water content perfectly encapsulates this dynamic. Flawed data is disseminated and promoted because it aligns with a predetermined narrative. Sound skepticism is attacked because it threatens that same narrative. Evidence of vindication is disregarded because its acknowledgement would necessitate admitting error. Throughout this entire episode, the object itself continues its celestial journey, indifferent to our academic disputes and professional rivalries. Joe Rogan inquired of Avi about the quantity of comets we have observed, aiming to establish a benchmark for comparison. Avi responded by stating, hundreds of comets, all behaving in accordance with predictable patterns, all conforming to our established models, and all explicable through conventional physics and chemistry. However, 3I Atlas deviates from this norm, disrupting multiple observed patterns concurrently. Its low water content, its counter-directional tail behavior, its near-perfect spherical form, and its nickel emissions all contribute to this anomaly. Each of these deviations, in isolation, might be dismissed. Coincidences do occur, and nature is inherently complex. But when these anomalies are considered collectively, when multiple seemingly impossible characteristics are observed within the same object, at some juncture, we must cease attributing them to chance and begin exploring their implications. The scientific method is intended to be our instrument for uncovering truth. One observes, forms a hypothesis, tests it, and refines it based on new data. This process is iterative and humble, premised on the understanding that our knowledge is incomplete and that any of our beliefs could be erroneous. Yet, at some point, for subjects that touch upon humanity's most fundamental questions and its position within the cosmos, the method has become compromised. Observation still occurs, but the formation of hypotheses has become constrained. Only certain hypotheses are deemed admissible, and only specific conclusions are permitted. Testing is encouraged, provided it reaffirms pre-existing beliefs. Anyone who steps beyond these boundaries, anyone who follows the data into uncharted territory, is labeled a contrarian, an attention seeker, or a pseudoscientist. These labels are strategically employed to isolate, marginalize, and send a clear message to other scientists: conform. Refrain from posing uncomfortable questions. Do not challenge the prevailing consensus. Your career depends on it. Avi Loeb possesses tenure at Harvard, has already garnered awards, published numerous papers, and mentored countless students. His career is secure, affording him the liberty to pose those uncomfortable questions and to pursue the data wherever it may lead. However, the majority of scientists are not in such a privileged position. Most scientists rely on research grants, require publications in prestigious journals, and depend on the approval of their peers. Consequently, they engage in self-censorship. They observe anomalies but refrain from mentioning them. They notice inconsistencies but do not investigate them. They opt for the safest course of action. The water controversy is not truly about water. It is about control. It concerns who has the authority to determine which questions warrant inquiry and which answers are acceptable. Presently, the scientific establishment has concluded that 3I Atlas must be classified as a comet, must be deemed natural, and must not fundamentally challenge our existing understanding. Data can be manipulated, observations can be explained away, and anomalies can be disregarded as long as the resulting conclusion remains comfortable. But comfort is not synonymous with truth, and 4% water content, confirmed by the most advanced telescope ever constructed by humanity, is not a comfortable finding. It is a problem. It is a problem that will persist regardless of our refusal to confront it directly. This visitor, the size of Manhattan, a formidable entity in our cosmic vicinity. When Avi stated, 3 Atlas is the size of Manhattan Island, he was not speaking metaphorically. He was being precise. If you have ever stood on Manhattan and gazed up at its towering structures, navigated its crowded streets, and felt the sheer density and magnitude of that island, you will comprehend the scale of what we are confronting. This is not some diminutive rock drifting through space. It is not a mere boulder. It is an object of such immense proportion and substance that comparing it to one of Earth's most iconic islands is the only effective means of conveying its true nature. Manhattan spans 13 4/10 miles in length and reaches a width of 2 3/10 miles at its broadest point, encompassing roughly 22 square miles of terrain packed with skyscrapers, millions of inhabitants, intricate infrastructure, and a rich tapestry of history and culture. Now, envision that entire island detached from Earth, launched into space, and propelled towards our sun from the remote reaches of interstellar space. This is the phenomenon we are witnessing, and it achieved its closest proximity today. The scale of this object is significant for several reasons. Firstly, its colossal size renders any notion of it being a fabrication impossible. This was Avi's response to the absurd accusation that he had somehow invented this entity. He remarked, "If I possessed the capability to place an object the size of Manhattan into space, visible to anyone with a telescope, I would wield more power than the Pope." This is a perfectly apt retort, as the Pope, at the very least, claims divine authority. What caliber of authority would be necessary to conjure a mountain into existence at a distance of 4 1/2 astronomical units from Earth? Beyond refuting speculative theories, the object's immense size provides crucial insight into what it can and cannot be. Small celestial bodies are commonplace. Fragmented asteroids, comets the size of houses, these frequently traverse past Earth, often unnoticed. However, objects the magnitude of Manhattan are rare and possess considerable significance. They contain vast quantities of mass, material, and potential energy. When an object of such immensity exhibits anomalous behavior, when it performs actions that smaller entities do not, it cannot simply be dismissed as a measurement error or an optical illusion. Avi emphasized during the interview that any individual on Earth can observe 3-eye atlas using commercially available equipment, such as a half-meter telescope, which is owned by amateur astronomers and readily orderable online. Advanced instruments like Hubble or Webb are not required, nor is access to classified military observatories. All that is needed is a decent telescope, and a clear night sky. The object is sufficiently luminous, substantial, and proximate that citizen scientists can independently verify the professional astronomical findings. This democratization of observation is vital, as it ensures that the data cannot be suppressed, classified, or controlled by clandestine government agencies or a consortium of skeptical scientists. 3-eye atlas is undeniably present for all to observe. Its observed phenomena are reproducible, and its anomalies are demonstrably real. This is not merely indistinct footage of aerial lights. It is concrete, verifiable, and repeatedly documented observation of something genuinely peculiar. The object's brightness directly correlates with its size. When viewed through a telescope, we are witnessing sunlight reflecting off an expansive surface. The intensity of this reflected light provides information about the surface area, while variations in brightness over time reveal its rotational characteristics and shape. We observe an object that reflects light with remarkable consistency, lacking the dramatic fluctuations one would expect from an irregularly shaped body. Consider the Moon for comparison. The Moon is spherical, and as it orbits Earth, we observe its various phases, yet its overall luminosity remains relatively constant, regardless of which side is facing us. This is typical of spheres. They present a consistent surface area in all directions. Now, imagine an object shaped like a potato or a cigar. As it rotates through space, sometimes its elongated side is visible, exposing a large surface area and resulting in a bright reflection. At other times, its narrower end is presented, revealing a small surface area and a dim reflection. The brightness of such an object would fluctuate considerably. 3-eye atlas, however, exhibits minimal brightness variations despite a confirmed 16-hour rotation period. This indicates a near-perfect spherical form, which is an unusual characteristic for an object of its magnitude. Celestial bodies are constantly subjected to impacts from other objects, leading to fracturing, fragmentation, and chaotic tumbling. They are rarely neat or symmetrical unless sufficient gravitational force is present to pull them into a spherical shape. For rocky or icy objects, this gravitational rounding necessitates a considerable mass, exceeding what should be attributed to 3-eye atlas. This presents a contradiction. The object is large enough to be readily observed, to display clear structural detail in its light signature, and to be studied by both amateurs and professionals, yet it is purportedly too small to have naturally assumed a spherical form through gravitational forces. Nevertheless, it is nearly spherical. The question remains, how? Joe directly questioned Avi regarding imaging capabilities, asking if actual photographs of the object itself were available, allowing for a visual assessment of its appearance. Avi responded that while a resolved image does not exist, they possess data from reflected light, spectroscopic analysis, and measurements of brightness over time. He characterized this as doing astronomy the old-fashioned way, inferring structure from light curves. However, he also made an interesting remark. If there had been footage from Mars' orbit, depending on the object's size, we might have obtained better imagery. This raises a pertinent question. Why would Mars be relevant? The trajectory of 3-eye atlas brought it into relative proximity with Mars's orbital path. While not close enough for a collision, it was sufficiently near that if observations had been conducted at the opportune moment with the appropriate instruments, imagery might have been captured. However, either such observations were not made, or, if they were, the images have not been released, which is perplexing given that Mars orbiters routinely capture photographs. NASA operates multiple spacecraft around Mars, as do European space agencies. If 3I Atlas passed anywhere near Mars's orbit during a window suitable for observation, photographic evidence should exist. The absence of such images prompts several considerations. Are they classified? Did we simply miss a valuable opportunity? Is the object smaller than we currently estimate, thus not yielding clear images? Or, and this is purely speculative, was there a decision to withhold high-resolution imagery of 3I Atlas, perhaps because it might raise more questions than it answers? Size also plays a crucial role in our understanding of composition. An object the size of Manhattan contains an immense quantity of material. Avi indicated that spectroscopic analysis reveals a water content of 4% by mass. While 4% of Manhattan's mass is still a considerable amount of water, equating to millions of tons, it also implies that 96% is composed of something else, presumably rock, possibly metals, and other compounds. The critical question is, what are these compounds, and in what proportions? This is where the mention of nickel becomes significant. Avi noted during the interview that 3I Atlas is shedding nickel, not iron, and not the typical amalgamation of silicates and carbonaceous materials found in comets. Specifically, it is shedding nickel. This is highly unusual. Nickel does exist in space, and metallic asteroids can indeed possess nickel-iron compositions. However, comets, which originate from the outer reaches of solar systems and are predominantly composed of ice, do not typically expel pure nickel. This suggests either that 3I Atlas formed in an environment vastly different from our own Kuiper belt or Oort cloud, perhaps an interstellar region where nickel-rich compounds are prevalent, or its composition is not natural. Nickel possesses noteworthy properties. It is dense, durable, resistant to corrosion, and highly useful for applications such as spacecraft construction, heat shielding, structural components, and reflective surfaces. While I am not suggesting that 3I Atlas is a spacecraft, if one were designing a large interstellar probe intended to withstand the harsh conditions of space for potentially millions of years, nickel would be a logical material to incorporate. Furthermore, if such a probe were shedding particles either through degradation or active outgassing, nickel would be detectable in its spectral signature. The immense size of 3I Atlas also influences our interpretation of its trajectory and behavior. Smaller objects are more susceptible to external forces such as radiation pressure, solar wind, and gravitational perturbations from planets, which can significantly alter their orbits. However, objects the size of Manhattan possess substantial momentum. Altering their trajectory requires a considerable application of force. Therefore, when 3I Atlas exhibited counter-tail behavior, with material flowing sunward during July and August, this was not merely a few dust particles being propelled in an unintended direction. It represented measurable, sustained directional expulsion of material from an enormous object, necessitating a significant energy source. Where did this energy originate? In the case of conventional comets, the source is solar heating. Ice absorbs sunlight, warms up, sublimates into gas, and the expanding gas carries dust particles along, a straightforward thermal process. However, 3I Atlas displayed this anti-tail phenomenon while still relatively distant from the Sun. At distances of 4 or more astronomical units, temperatures are frigid, far too low for significant water ice sublimation, especially from an object that comprises only 4% water by mass. Consequently, what was driving this activity? What provided the energy to expel material with sufficient force and directionality to form an observable anti-tail? And why did this activity cease in September? Did the object cool down? This is unlikely, as it was approaching the sun, not moving away. Did it deplete its volatile materials? This is a possibility, but if so, why did a normal tail subsequently appear? If volatiles were exhausted, the object should have become dormant, not transitioned to a different mode of activity. This suggests an alternative explanation. The activity is controlled. It implies that something on or within that Manhattan-sized object made a decision to alter its operational mode, to cease one action and commence another, to switch from an anti-tail to a normal tail. This change would not be dictated by fluctuating external conditions, but by internal decision-making processes. I am consistently drawn back to the word decision because every aspect of 3I Atlas's behavior implies deliberate action. The timing, the transitions, the anomalies that manifest and then disappear. Natural processes are gradual and respond predictably to external forces. Warming a comet causes it to outgas. Cooling it causes the activity to cease, a simple cause and effect relationship. However, 3I Atlas does not adhere to this pattern. It performs an impossible action, then stops, then engages in a seemingly normal but insufficient activity as if it were testing, signaling, or malfunctioning. While Avi did not employ such language in the interview, recognizing his meticulous nature, his point was evident when Joe pressed him with the analogy of an animal in the backyard. Describing the observation of a creature with a tail extending from its forehead and a mass 1,000 times greater than a cat, the implication was clear. When a sufficient number of anomalies accumulate, when an object is large and peculiar enough and consistently deviates from expectations, one must question the initial classification. It is not a cat, even if it bears a superficial resemblance from a distance and is found in a location where cats are typically encountered. Similarly, 3I Atlas is not a comet. It may exhibit superficial comet-like characteristics and may be located in the inner solar system where comets are commonly found, but it is not a comet. So, what is it? That is the question Avi is posing, the question the scientific community is refusing to seriously investigate. To genuinely ask this question necessitates considering answers that would undoubtedly cause widespread discomfort. It requires allocating resources to observations that could potentially reveal paradigm-shifting discoveries. It involves risking one's professional reputation on data that might ultimately prove to be mundane. However, the inherent risk in this situation is noteworthy. When confronting an object the size of Manhattan originating from interstellar space, displaying multiple simultaneous anomalies during the most significant close approach we will witness in our lifetimes, the risk associated with insufficient investigation far outweighs the risk of appearing mistaken. Because if there exists even a remote possibility that 3I Atlas is something other than a celestial rock, if there is even a chance that we are observing the first confirmed close encounter with extraterrestrial technology, then every telescope on Earth should be directed towards it at this very moment. Every instrument at our disposal should be actively gathering data, and every scientist capable of contributing should be engaged in its analysis. Instead, we are presented with press releases concerning water content from teams relying on flawed data. We are met with silence from the scientific establishment. We are subjected to conspiracy theories about distractions related to Epstein's files. And we have one Harvard professor, persistent, brilliant, and unwilling to look away, repeatedly stating, "This is unusual. We must investigate. Allow us to follow the data." The sheer size of 3I Atlas precludes us from claiming ignorance. We cannot assert that it was too faint to detect or too distant to study. It is here, It is enormous, and it is observable. And today, October 29th, at its perihelion, it is at its closest point to Earth. Whatever data we can acquire, we must gather now. Whatever observations are feasible, we must undertake them now. Because this mystery, the size of Manhattan, will not patiently await our overcoming of fears and prejudices. It will continue on its trajectory, returning to the darkness, leaving us with incomplete data and unresolved questions, unless we choose a different path. Unless we decide that the pursuit of truth holds greater significance than maintaining comfortable illusions. Unless we acknowledge that sometimes, just sometimes, the seemingly impossible entity in your backyard is not a cat at all. Shedding nickel and secrets, the chemical signature of the unknown. There is a point in the Joe Rogan interview where Avi mentions, almost as an aside, that 3 Atlas is shedding nickel. If one is not paying close attention or does not grasp the profound implications of this statement, it could be easily overlooked. Joe moved past this detail quickly, and the conversation continued. However, this single observation, this chemical fingerprint, may very well represent the most compelling evidence we possess that something fundamentally extraordinary is occurring with this object. Nickel, not iron, not the standard mixture of rocky silicates, not the organic compounds found in primitive carbonaceous asteroids, not the water ice and carbon dioxide typically expected from comets. Nickel, a pure element, has been detected through spectroscopic analysis of material ejected from the object. This finding is significant because when we examine light from comets, we observe emission lines, specific wavelengths, where atoms and molecules absorb or emit photons. Each element possesses a distinctive spectral signature, much like a human fingerprint. When solar radiation warms a comet, various substances sublimate and release gases, which we can identify by their spectral lines. Water is clearly evident, as are carbon monoxide, carbon dioxide, cyanogen, and a range of organic compounds. We possess extensive data spanning decades detailing the composition of comets and the substances they release as they journey closer to the Sun. Nickel is notably absent from this conventional list. While trace quantities of metals can be present in space, incorporated during solar system formation, and small amounts of many elements can be found if one looks meticulously, the shedding and detectable release of nickel as a primary emission product is not characteristic of comets. This behavior is indicative of asteroids, specifically metallic asteroids. These are objects that formed in the intense inner regions of a solar system, where temperatures were sufficiently high for metals to condense, while volatile substances like water were vaporized and driven away. Consequently, we encounter an immediate contradiction. Object 3 Atlas exhibits cometary traits in some respects, possessing a surrounding coma, demonstrating outgassing activity, and developing both a normal and an anti-tail. These are hallmarks of comets. However, its composition points towards a metallic asteroid. These two classifications are mutually exclusive. Comets originate in the frigid outer reaches of star systems, where ice is prevalent, whereas metallic asteroids form closer to stars in scorching environments dominated by rock and metal. An object cannot naturally belong to both categories. This suggests the object might not have formed naturally, but was instead engineered. If one were constructing a craft designed for interstellar travel, metals would be essential construction materials chosen for their durability and heat resistance. Nickel perfectly fits this profile. Nickel possesses remarkable properties making it ideal for space applications. It is dense, but not excessively heavy compared to other metals, exhibits superior corrosion resistance to iron, and maintains its strength across a broad spectrum of temperatures. It can be alloyed with other metals to create materials with tailored characteristics, and crucially, it effectively reflects certain wavelengths of light, which is important for mitigating radiation exposure during prolonged journeys between stars. Modern spacecraft extensively utilize nickel alloys. The International Space Station incorporates nickel components, satellites employ nickel-cadmium batteries, and heat shields often include nickel for its thermal resilience. If humanity can recognize the utility of nickel for space technology with our current, relatively primitive capabilities, one can only imagine what a highly advanced civilization could achieve with it. It is important to clarify that the presence of nickel alone does not conclusively prove 3 Atlas is artificial. Its significance lies in the context. The emission of nickel, coupled with the presence of an anti-tail, a low water content, a near-spherical shape, and observed behavioral shifts. No single anomaly is definitive. However, when these disparate observations are considered collectively and multiple improbable characteristics are present in the same object, the likelihood of them all being natural coincidences diminishes to near zero. There is an additional aspect to the nickel emission that was not elaborated upon during the interview, but warrants consideration: the mechanism of its release. With water ice, the process is straightforward. Solar heating causes sublimation, directly transforming ice into gas. This gas then expands, carrying dust particles along. However, nickel does not sublimate at the temperatures encountered. Its boiling point is 2,913 degrees Celsius. Even at its closest approach to the Sun, 3 Atlas does not reach temperatures even remotely close to vaporizing nickel. Therefore, the nickel must be present in particulate form as minuscule grains expelled by an alternative process. But what process could that be? If the nickel were embedded within ice, the sublimation of the ice would be expected to release a mixture of materials, not predominantly nickel. If it were being ablated from the surface by solar wind or micrometeorite impacts, one would anticipate a gradual, continuous release, not the variable emission being observed. If it is being actively expelled, propelled outward by internal pressure or mechanical means, then we are led back to the consideration of artificial systems. A hypothesis, not mentioned in the interview but worth exploring, is that 3 Atlas could be a fragment of a larger metallic celestial body that fractured. It might be a piece of a disintegrated planet ejected during a catastrophic collision in another solar system eons ago. This would account for its metallic composition. However, it would not explain its observed activity. Inert fragments do not outgas, develop anti-tails, or alter their behavioral modes. They simply drift silently through space, inanimate and cold. Spectroscopic data from 3 Atlae reveals other intriguing features beyond nickel. There are emission lines consistent with the production of cyanide. For context, cyanide is not unusual in comets. Many comets generate cyanogen and related compounds as they heat up. However, the ratio of cyanide to water in 3 Atlas is anomalous. Given the confirmed low water content, the observed quantity of cyanide being produced is significantly higher than expected. Cyanide production in comets typically arises from the breakdown of more complex organic molecules requiring specific carbon and nitrogen configurations and sufficient energy to drive the chemical reactions. But with only 4% water by mass, where are these complex organic molecules originating? Where is the carbon source? And why is it specifically producing cyanide rather than other potential breakdown products? I am not suggesting 3 Atlas is intentionally generating cyanide as a weapon or defense. Rather, the chemistry is inconsistent with a natural object possessing the composition we have measured. The pieces simply do not fit together. It is akin to discovering a vehicle engine that runs on water expels gasoline as exhaust, and has a transmission constructed from glass. While each individual component might exist in nature, their combination is illogical. During the interview, Avi discussed his experiences with other scientific controversies, recounting instances where teams claimed to detect water, but their measurements were flawed, and he faced criticism for identifying these data discrepancies. A similar pattern can apply to compositional analysis. When spectroscopic data reveals something unexpected, something that deviates from the established narrative, there is immense pressure to reinterpret it, to explain it away, or to find an alternative interpretation that renders it conventional. Perhaps this is occurring with the nickel. It's conceivable that scientists examining those spectral lines considered the possibility of nickel, but also a more familiar compound, opting to identify it as the latter to maintain consistency. It is possible that the data has been subtly adjusted to appear less alarming, or that public reports represent sanitized versions of the raw observations. I have no definitive proof of this, but given the history of the water detection controversy and the inherent resistance within institutions to acknowledge anomalies, it would not be surprising. There is one further element to the nickel enigma that warrants attention. Metallic objects in space exhibit different thermal properties compared to icy ones. Metal conducts heat efficiently, absorbing radiation and distributing it throughout its structure. Ice, conversely, acts as an insulator, absorbing heat locally, sublimating, and carrying heat away as gas. These distinct thermal behaviors influence how an object reacts to sunlight, how its temperature fluctuates with its distance from the sun, and, critically, how it radiates infrared light. We have infrared observations of 3IL. Multiple telescopes have measured its thermal emission, and the publicly released data indicates thermal behavior more consistent with a solid object than a porous ice mass. The temperature distribution is more uniform than one would expect for a comet. The manner in which it cools during its rotation suggests efficient heat distribution, implying good thermal conductivity, which in turn suggests a significant metal content. Again, no single measurement is conclusive. However, the infrared data supporting metallic content, combined with the spectroscopic detection of nickel emission and all other corroborating evidence, collectively points in the same direction. This object possesses substantial metallic components, and metallic comets do not occur naturally. At one point, Joe inquired about how composition is determined when physical contact is impossible. Avi explained spectroscopy, emphasizing how light carries information and allows us to decipher chemical signatures. What he did not fully elaborate on, and what the interview did not deeply explore, is the extent of interpretation involved in this deciphering. Spectral lines can overlap, signals can be ambiguous, and background noise can contaminate measurements. When dealing with a unique object, lacking comparable cases, and observing emissions never seen before, the interpretation becomes subjective. Whose interpretation should we trust? That of the teams that prematurely publish water detections with questionable data? The established scientists who insist on conventional explanations for everything? Or the solitary voice pointing out, "Look, this is genuinely unusual. We need to investigate more rigorously." The nickel emission is an undeniable fact, present in the data and confirmed by multiple independent observations. This is not a measurement error or an instrumental artifact. 3 Atlas is releasing nickel into space as it traverses our solar system. Until a plausible natural mechanism can be provided for how an interstellar object exhibiting cometary activity can be predominantly metallic and actively shedding elemental nickel, we must entertain the possibility that the object is not of natural origin. Consider the fate of a spacecraft after millions of years in space. Micrometeorite impacts, cosmic ray bombardment, thermal cycling, and gradual material degradation would take their toll. If 3 Atlas is ancient technology, having traveled for eons, it would inevitably shed particles. Protective coatings would erode, and structural components would develop microfractures. If these components are nickel-based, spectroscopy would indeed detect nickel. I am not asserting this as a definitive explanation, but it aligns better with the available data than any natural explanation presented thus far. The fact that the scientific community is not seriously exploring this possibility, and that suggesting it leads to being labeled a pseudoscientist or attention seeker, reveals more about the sociology of science than about the intrinsic nature of 3I Atlas. The chemical fingerprint is undeniable, imprinted in light, verified by multiple instruments, and reproducible and verifiable. Nickel, not in trace amounts or as a minor spectral feature, but as a significant emission product. This fingerprint conveys a message. Whether we choose to heed it, whether we possess the courage to explore its implications, is our prerogative. The data remains indifferent to our comfort, and the nickel remains indifferent to our theories. It is present in the spectrum, awaiting a brave individual to accurately interpret its meaning. The sphere that defies existence, shape, spin, and inherent impossibilities. 16 hours. This is the duration it takes for 3 Atlas to complete a single rotation. We know this with absolute certainty through measurement. As the object spins, the amount of sunlight it reflects fluctuates subtly, causing a periodic variation in brightness. 16 hours, consistently and measurably. However, what should logically occur, and does not, is a dramatic shift in brightness. It should fluctuate significantly between bright and dim as different surface areas face Earth, but the variation is minimal. Avi explained this phenomenon to Joe using fundamental physics. An elongated object, such as a cigar or a potato shape, tumbling through space, will present different surface areas to observers. At times, its long side, with a large reflective surface, will be visible. At other times, its narrow end, with a minimal surface area, will be seen. The difference in brightness between these orientations can be factors of 2, 3, or even 10 for highly elongated objects. We observe this routinely with asteroids. Their light curves reveal their shapes. 3I Atlas exhibits almost no such variation, perhaps a mere 10 to 15% brightness change over its 16-hour rotation. This is the signature of an object that is nearly spherical. Not perfectly so, as minor irregularities exist, but sufficiently symmetrical that its rotation has a negligible impact on the reflected light. This is fundamentally incongruous for an object of its size and purported origin. Small celestial bodies in space are inherently irregular. They form through collisions, accretion of smaller fragments, and gravitational capture of debris, processes that are chaotic and violent, resulting in asymmetrical, lumpy shapes. Examine any asteroid visited up close. Eros, Itokawa, Bennu, Ryugu, all are irregularly shaped, bearing craters, boulders, flat surfaces, and ridges, devoid of smoothness or symmetry. Larger celestial bodies can achieve spherical form, but only if they are massive enough for their own gravity to overcome the structural integrity of their constituent rock. This threshold is known as the hydrostatic equilibrium limit. For rocky bodies, this limit is approximately 500,000 kilometers in diameter, varying with composition. Below this size, an object lacks the gravitational force to compress itself into a sphere. Above it, gravity dominates, pulling all material towards the center and forming a round body. This explains why planets are spheres and asteroids are not. 3A Atlas is estimated to be between a few kilometers and perhaps 20 kilometers in diameter based on brightness and distance estimates. This size is far too small to achieve hydrostatic equilibrium if composed of rock or ice. It should possess a potato-like shape and exhibit significant brightness variations as it rotates. Yet it does not. This implies either our size estimation is incorrect and the object is substantially larger than we believe, which would necessitate it being significantly darker than any known solar system object, or it is not held together solely by gravity. Something else is maintaining its shape, something structural, something engineered. During the interview, Joe inquired if imaging could determine the shape, to which Avi responded negatively, stating that resolved images are unavailable and the shape is inferred from the light curve. However, he also noted the confirmed 16-hour rotation period, indicating that this object has been observed for months, with data collected across multiple observation windows, and the findings remain consistent: minimal variation and a near-spherical shape. In spacecraft design, there is a concept known as structural integrity. When constructing an object intended to endure interstellar space, withstand thermal stress, impacts, and millions of years of radiation exposure, materials are not haphazardly assembled. A deliberate structure is designed, a framework engineered to distribute stress, maintain shape, and protect internal components. The most efficient structure for distributing stress in all directions is a sphere. Geodesic domes, ball bearings, and pressurized tanks all exemplify this principle. Architects and engineers on Earth recognized this long ago. Spheres are inherently strong, possessing the minimum surface area for a given volume, thereby minimizing material usage, and exhibiting no stress concentrations at corners or edges, responding uniformly to external pressure. If designing a probe for interstellar transit, a sphere or near-sphere would be a logical selection. Natural objects, however, do not adhere to engineering principles. They are governed by the unpredictable, chaotic rules of collisions, gravitational interactions, and random accretion. They are not optimized or efficient. Their shape is merely a consequence of their formation process and subsequent evolution, and that shape is never a perfectly symmetrical sphere unless gravity compels it to be. 3 Atlas presents us with an impossibility. It is too small to be naturally spherical, yet it is spherical. It is rotating through space with a measurable period, yet its brightness scarcely changes. The data is unequivocal, the observations are repeatable, and the conclusion is inescapable. This object maintains its shape through means other than natural processes. Another aspect of its rotation merits scrutiny. 16 hours is a relatively slow rotation for an object of this size arriving from interstellar space. Smaller bodies tend to spin faster due to prolonged tumbling over millions or billions of years, accumulating angular momentum from countless minor impacts. A 16-hour rotation suggests either the object is more massive than we estimate, reintroducing the size discrepancy, or its spin rate has been deliberately controlled. A controlled rotation rate would be logical if the intention were to simulate gravity for biological occupants. 16 hours is not quite sufficient for comfortable artificial gravity via centripetal force, but it falls within a plausible range. Alternatively, the rotation might serve another purpose, such as thermal management, preventing one side from overheating while the other freezes, or distributing power generation if solar collectors are present on the surface, or maintaining attitude control and stability during a lengthy voyage. I am now venturing into speculation, extrapolating beyond what the data strictly supports. However, the data itself, the 16-hour rotation coupled with minimal brightness variation, is not speculative. It is a measurement, and it does not align with any known natural formation scenario. Avi drew an interesting parallel during the interview, referencing Arthur C. Clarke's novel Rendezvous with Rama, which features a cylindrical alien spacecraft entering the solar system. The spacecraft in the novel is tens of kilometers in length, rotates to generate artificial gravity, and passes through the solar system without stopping or communicating, merely a brief visit before continuing into the void. The parallels to 38 are evident: a large object from interstellar space, an unusual shape, controlled rotation, and a brief passage through our cosmic neighborhood. Clarke penned that novel over 50 years ago, in 1973, and somehow envisioned almost precisely what we are now observing. Was he prescient, merely fortunate, or did he extrapolate from fundamental principles, recognizing that if alien technology were to visit us, it would appear strange but not random, designed yet unfamiliar? Following engineering logic, we might comprehend it even if we could not replicate it. The distinction between Clarke's cylinder and 3-Atlas's sphere might be insignificant. Both shapes offer structural advantages and would appear anomalous compared to natural objects. Both would likely rotate, as rotation addresses multiple challenges in long-duration spaceflight: stability, thermal management, and potentially artificial gravity. The specific geometry is less critical than the mere existence of geometry itself, that the object possesses a defined, maintained shape rather than the random irregularity of asteroids. Joe pressed Avi on whether the object could still be natural, whether an obvious explanation might be overlooked. Avi consistently returned to the same point: we must determine why it is so unusual rather than assuming natural origins and working backward. We should not dismiss anomalies because they are uncomfortable, but rather investigate them thoroughly to understand what we are observing. Rigorous investigation of the shape, however, requires superior data than we currently possess. We need resolved imaging to actually see the object, not merely infer its properties from brightness variations. Obtaining this requires either extraordinary luck with orbital assets around Mars, which may or may not have successfully gathered any pertinent data, or patience for the next visitor from beyond our star system, and ensuring we are equipped with the appropriate instruments in precisely the right locations at the opportune moments. Currently, as 3IE Atlas reaches its closest orbital point, known as perihelion, it is at its absolute brightest and most accessible. If there is ever a time to capture definitive imagery, it is now. Yet, to my knowledge, no dedicated observation initiatives have been launched. No space organizations have repositioned their equipment to maximize data acquisition. The celestial body is merely transiting, receiving no special scrutiny beyond routine astronomical surveillance, leaving us dependent on whatever observations amateur astronomers and university observatories happen to direct toward it. This situation can only be described as pure and unadulterated negligence. We are encountering a potentially paradigm-altering object during its closest approach, exhibiting numerous peculiarities, including seemingly impossible geometric properties, and the scientific community's response amounts to a collective indifference. Some academic papers will undoubtedly be produced, and some data will eventually be analyzed, but there is no concerted effort, no grand undertaking akin to the Manhattan Project for investigating interstellar phenomena, and no acknowledgement that we might be witnessing the most significant astronomical discovery in human history. The near-perfect spherical form of 3IE Atlas is not a subtle characteristic. It is not an ambiguous case where one could, with sufficient conjecture, argue for natural formation processes. Its shape is unequivocally apparent. The light curve data is anomalous. Its rotational period has been measured. The fluctuation in its brightness is minimal. These are established facts, not matters of interpretation, and facts that challenge our established understanding of how natural celestial bodies behave ought to provoke intense scientific curiosity, not defensive rationalizations. There exists a fundamental principle in scientific inquiry known as Occam's razor. When faced with multiple potential explanations for a phenomenon, the simplest explanation is generally preferred. However, simplest does not imply most convenient or most comfortable. It signifies the explanation that necessitates the fewest unsupported assumptions. The hypothesis positing a natural cometary origin for 3IE Atlas demands the assumption of several highly improbable coincidences. This includes an unusual composition, peculiar thermal behavior, anomalous gas expulsion, and a perfectly spherical shape despite insufficient mass to naturally maintain such a form. While each individual assumption might be plausible on its own, their cumulative improbability renders the entire scenario far-fetched. Conversely, the hypothesis of an artificial object requires only a single foundational assumption: that technologically advanced civilizations exist elsewhere in the cosmos and occasionally dispatch probes to other star systems. We know this is a possibility because we are such a civilization ourselves. We understand the feasibility of interstellar probes because we have conceptualized and even initiated such projects, with the Voyager missions serving as a prominent example. Therefore, the artificial origin explanation necessitates assuming that something we already know to be achievable has occurred beyond the confines of Earth. This is demonstrably simpler and involves fewer speculative leaps. This is Occam's razor applied correctly. However, many individuals are not seeking simplicity. They are seeking reassurance. They prefer explanations that do not disrupt their existing worldview. They desire to believe in humanity's solitary existence or, at the very least, that any extraterrestrial intelligence would maintain a respectful distance and refrain from appearing in our telescopes, performing inexplicable feats. The presence of a sphere that defies conventional understanding poses a threat to this comfort. It compels us to confront possibilities we would rather avoid. 16 hours of rotation, minimal brightness variation, and an almost perfect spherical form are undeniable facts. They are observations recorded in photometric data, measured by sophisticated instruments, and corroborated by multiple independent observers. These facts collectively indicate that 3IE Atlas is not what we wish it to be. It is not a reassuringly conventional chunk of ice and rock adhering to predictable natural laws. It is something fundamentally different, something that retains its shape through deliberate design rather than gravitational forces, something that rotates with an apparent purpose rather than through chaotic tumbling. The existence of this sphere is a reality, irrespective of our willingness to acknowledge it. The crucial question is whether we possess the fortitude to accept the implications of this discovery. This situation evokes Pascal's Wege, a philosophical argument concerning the rationality of belief in God and the concept of black swan events, which are unpredictable occurrences with potentially severe consequences. Blaise Pascal, in the 17th century, was not contemplating extraterrestrial spacecraft when he formulated his renowned wager. His focus was on the existence of God, matters of faith, and the process of making rational choices when confronted with uncertainty. However, the logical framework he developed for evaluating infinite consequences against finite probabilities is perfectly applicable to the phenomenon of 3IE Atlas. Avi, who understands this perfectly, meticulously walked Joe through this reasoning during their discussion. He articulated that while the probability of God's existence might seem low, the implications, should God indeed exist, are infinite, encompassing eternal salvation or damnation, infinite reward or infinite punishment. Consequently, even if the probability is exceedingly small, even if one is 99% certain of God's non-existence, that 1% possibility, when multiplied by infinite consequences, demands serious consideration and a corresponding course of action as if it were true. Now, let us substitute alien technology for God. The probability might indeed be small. Most scientists would likely deem it very small. They would contend that the overwhelming majority of interstellar objects are natural in origin, that anomalies can be accounted for by exotic yet natural processes, and that we should default to conventional explanations until definitively compelled to explore alternatives. Very well, let us assume the probability that 3IE Atlas is artificial is merely 1%, or even 1/10 of 1%. Does this justify disregarding it? Absolutely not, because the implications, while not infinite, are profoundly civilization-altering. If 3IE Atlas represents alien technology, then everything changes. Our understanding of our cosmic position, our technological progression, our societal structures, our economic systems, and our political landscape would all be fundamentally reshaped. Markets would experience unprecedented volatility, potentially crashing and rebuilding overnight. Governments would face existential legitimacy crises. Religious institutions would be compelled to reevaluate their entire cosmologies. Scientific paradigms would be dismantled, giving rise to entirely new frameworks. The human narrative would be irrevocably altered in ways we cannot currently anticipate. This is precisely what Avi means when he refers to Pascal's wager in the context of alien technology. The stakes are so immense that even scenarios with an infinitesimally low probability warrant rigorous investigation. This is not mere fanciful speculation, it is fundamental risk assessment. Intelligence agencies grasp this concept intuitively. They do not dismiss low-probability, high-impact threats simply because they appear improbable. Instead, they investigate, they prepare, and they treat them with the gravity their potential consequences demand. Avi then introduced the analogy of October 7th, referencing the intelligence failure in Israel and the Hamas attack that caught everyone by surprise despite prior indications. He did not raise this point casually. As an Israeli citizen, he has personal connections to those affected by that catastrophic event and possesses a profound understanding of how intelligence breakdowns occur. The prevailing theory suggests that nothing will happen. Incoming data then hints at the possibility of an impending event. However, this data contradicts the established theory, and theories, by their nature, offer comfort and certainty. Consequently, the contradictory data is dismissed, rationalized away, or subjected to scrutiny designed to cast doubt upon it. Subsequently, the low-probability event materializes, leading to tragic loss of life. The scientific establishment operates under a prevailing theory regarding interstellar objects. They are rocks, comets, natural formations. This theory is comforting, aligning with our current scientific understanding and not requiring a fundamental re-evaluation of existing assumptions. Nevertheless, a continuous stream of data emerges that contradicts this theory. Consider Oumuamua, which accelerated without discernible outgassing. Then there is 3IE Atlas, with its anti-tail, its nickel emissions, its spherical geometry, and its behavioral transitions. Anomaly follows anomaly, each explained away in isolation, while the collective pattern remains unacknowledged. This mirrors the precise mechanism of intelligence failures. Avi's point is that the consequences of being mistaken in this instance, of dismissing anomalies because they challenge a comfortable theory, are colossal. We cannot afford to repeat the mistake of October 7th with 3IE Atlas. We must not permit theoretical preferences to supersede empirical observation. Because if we are wrong, if we disregard this phenomenon and it subsequently proves to be the first confirmed detection of alien technology, we will have squandered humanity's most significant scientific opportunity. Joe grasped this immediately and countered with the obvious question. Could this still be a natural occurrence? Avi's response was exemplary. Yes, it could be. Our task is to determine why it is so unusual, not to assert that it must be natural and then retroactively justify that conclusion. We should not dismiss the possibility of artificial origin. Instead, we must actively investigate, treating this as the high-stakes scenario it unequivocally is. We need to apply the principles of intelligence agency analysis to astronomical observation. In risk analysis, there is a concept known as black swan events. While popularized by Nassim Taleb, the underlying idea is considerably older. A black swan is an event that appears impossible until it actually occurs. Prior to European exploration of Australia, the prevailing belief was that all swans were white. Every swan ever observed, every swan documented in historical records, was white. The theory was considered robust. Swans are white. Then explorers encountered black swans in Australia, and the established theory collapsed. What was deemed impossible was, in fact, real. However, the crucial insight regarding black swans is that preparation is possible even without precise prediction. One can construct systems resilient enough to withstand unexpected shocks. Overconfidence in existing models can be mitigated. Flexibility and an openness to anomalous data can be maintained, and one can recognize that the absence of a past occurrence does not preclude its future occurrence. We have never confirmed the existence of alien technology. Every anomalous signal, every peculiar observation, every UFO report has, in the past, been ultimately resolved as something natural, human-made, or a simple misidentification. The historical record is unambiguous. Aliens have not visited our planet. Alien probes have not entered our solar system. This is the basis of the white swan argument. We have only ever observed white swans, therefore swans are white. Consequently, this object in our solar system must also be a white swan, even if it exhibits seemingly black characteristics. But Australia exists. Black swans exist, and the universe is vastly larger and older than Australia. The Milky Way galaxy alone contains 100 billion stars. Many of these stars formed billions of years before our Sun. Billions of potentially habitable planets have existed for far longer than Earth. Intelligence emerged here from fundamental chemistry. That same chemistry exists universally. The same laws of physics apply everywhere. Therefore, the probability that humanity is the sole and first technological civilization is vanishingly small. This implies that black swans are not merely possible, they are inevitable. At some point, somewhere, a human observer will direct a telescope towards something originating from interstellar space and realize they are looking at technology. The only remaining questions are whether that observer will have the courage to voice this realization and whether the scientific community will possess the wisdom to listen. Avi is striving to be that observer. He examined Oumuamua and stated that its peculiarities warranted serious investigation. He was subsequently attacked, ridiculed, and marginalized, labeled a publicity seeker. Now, 3IE Atlas has emerged with even more anomalies, and he is reiterating the same message. Investigate seriously. Consider all possibilities. Do not let observation be dictated by preconceived notions. And the reaction from the establishment remains consistent: dismissal, rationalization, and attacks on his credibility. This is the identical pattern of October 7th unfolding in real time. Data contradicting the prevailing theory. The theory prevailing because it offers comfort. warnings disregarded because they challenge the established consensus, and the low-probability, high-impact event steadily approaching while attention is diverted elsewhere. Intelligence agencies, when functioning optimally, employ processes designed to circumvent this pitfall. They conduct red team exercises where individuals are tasked with arguing the opposing viewpoint to the prevailing consensus. They maintain multiple hypotheses concurrently. They prevent any single theory from becoming so dominant that contradictory evidence is automatically disregarded. They understand that the cost of being wrong about a black swan event far outweighs the cost of being excessively cautious about white swans. Science requires similar discipline. We need institutional frameworks that actively encourage the pursuit of anomalies, that shield researchers who challenge established consensus, and that allocate resources towards investigating possibilities that are low in probability but high in potential impact. Currently, we observe the opposite. We have systems that penalize deviations from orthodoxy, reward confirmations of existing theories, and tie career advancement to a risk-averse approach. This not only disadvantages individual scientists, but is detrimental to humanity as a whole, particularly as we are living through an unprecedented moment in history. For the first time, we possess instruments with sufficient sensitivity to detect interstellar objects as they traverse our solar system. For the first time, we can meticulously observe them, measure their characteristics, and track their movements. We are opening a new observational window onto the cosmos, and what we glimpse through it could fundamentally alter our understanding of everything. However, this will only be possible if we actively look, if we allocate the necessary resources, if we treat our observations with the seriousness they deserve, and if we apply the principles of Pascal's Wage and intelligence agency risk analysis to the question of our cosmic solitude. Avi mentioned during the interview that no federal funding has been allocated to the search for technological signatures, amounting to zero. In stark contrast, $10 billion is dedicated to the search for microbial biosignatures. This allocation is not scientifically driven, it is an ideological choice. It reflects an implicit assumption that intelligence is exceedingly rare or entirely absent, that the search for technology is not worthwhile, and that we can safely ignore the possibility of alien probes in favor of focusing on alien microbes. While the discovery of microbes would indeed be scientifically intriguing and philosophically significant, the detection of technology would be practically transformative. Microbes, by their nature, can offer insights only into their own biology. Technology, however, could contain profound information. It could reveal physical principles we have yet to discover. It could fundamentally reshape our understanding of what is possible. The disparity in investment versus potential return is stark. This scenario is precisely what Pascal's wager was designed to address. Even if the probability is low, the magnitude of the potential outcome justifies a significant allocation of resources. Yet, we are failing to do so. We are making the same error that intelligence agencies made prior to October 7th. We adhere to a comfortable theory, persisting with it regardless of the evidence presented. Today, as 3IE Atlas reaches its perihelion, we face a critical choice. We can continue to dismiss anomalies, explaining away each peculiar observation individually, thereby preserving our comfortable belief that interstellar objects are merely rocks. Or we can acknowledge that the simultaneous presence of multiple anomalies within a single object necessitates thorough investigation. We can implement proper risk analysis. We can treat this phenomenon as the potential black swan event that it is. The consequences of being mistaken are not infinite, as in Pascal's original wager, but they are substantial. They are substantial enough that a 1% probability multiplied by civilization. Altering consequences mandates serious investigation. They are substantial enough that dismissing this possibility is not an act of scientific caution, but one of institutional timidity. They are substantial enough that history will judge us harshly if we allow this unparalleled opportunity to slip away simply because we were too fearful to admit we might be witnessing something unprecedented. Avi concluded this portion of the conversation by stating, "Intelligence agencies will not repeat the mistake of October 7th. They have learned. They have adapted. The question is whether the scientific community can similarly learn the same lesson, whether we can recognize that low probability does not equate to no probability, whether we can construct institutions resilient enough to contemplate black swan possibilities without succumbing to conspiratorial thinking or abandoning empirical rigor. The wager is on the table. The stakes are clear, and 3IE Atlas is forcing our hand. We can fold, dismiss it as natural, and proceed with our comfortable theories intact, or we can call, investigate seriously, and potentially win the most significant prize in scientific history. Pascal would know which choice to make. Intelligence analysts would know. The question is whether scientists, who are ostensibly trained to follow evidence wherever it leads, can muster the same courage. Rendezvous with Rama, when science fiction predicts reality. Arthur C. Clarke passed away in 2008. He never witnessed Oumuamua. He never saw 3IE Atlas. Yet, remarkably, 35 years before the first confirmed interstellar object entered our solar system, he chronicled its story. While he did not foresee the specific details, the precise measurements, or the spectroscopic signatures, he captured the essential narrative: a colossal object from the deep reaches of space, of artificial origin, traversing our solar system without pause, leaving humanity with more questions than answers. Rendezvous with Rama was published in 1973. The narrative is straightforward. Astronomers detect an anomalous object approaching the solar system. It is immense, cylindrical, and rotates with a precise periodicity. Humanity dispatches a spacecraft to intercept it. The crew explores its interior, encountering vast empty expanses, enigmatic structures, and dormant machinery. They come to the realization that they are within a starship, albeit one so alien that comprehending its purpose proves exceedingly difficult. Then, before they can glean further knowledge, Rama accelerates using an unknown propulsion system and departs, heading back into interstellar space. There is no communication, no explanation, merely a brief visit and departure. When Avi mentioned Rama during the interview, Joe immediately recognized the striking parallel. Clarke envisioned a cylindrical object tens of kilometers in length. 3IE Atlas is spherical and smaller, though still substantial by asteroid standards. Clarke's Rama was designed to rotate, generating artificial gravity. 3IE Atlas rotates with a 16-hour period. Clarke's Rama displayed no inclination to communicate with humanity. 3IE Atlas has exhibited no discernible signals or attempts at contact, only its inexplicable behavior and mysterious properties. The specific geometry differs, a cylinder versus a sphere. However, the underlying concept is identical, an artifact from another civilization passing through our cosmic vicinity, pursuing its own incomprehensible agenda, indifferent to our existence. And here lies the profound prescience of Clarke's vision. He understood that first contact might not resemble cinematic portrayals. It might not involve a landing on the White House lawn, the broadcasting of messages, or engaging in direct dialogue. It might simply consist of detection, observation, and the gradual realization that we are observing something manufactured rather than naturally formed. Clarke was a scientist before he was a writer. He held degrees in physics and mathematics. He worked with radar technology during World War II. He proposed the concept of geostationary satellites decades before they were technically feasible. He possessed a deep understanding of orbital mechanics, thermodynamics, and the practical constraints of space travel. When he conceptualized what an interstellar probe might entail, he was not engaging in fantasy. He was extrapolating from fundamental engineering principles. A cylindrical design is logical for a rotating habitat as it facilitates uniform artificial gravity along its internal surface. A spherical shape offers structural integrity and efficient material utilization. Both designs address the fundamental challenges of interstellar travel: protection from radiation, thermal management, and stability. Both would appear anomalous when compared to natural celestial bodies and would exhibit behaviors that defy our expectations derived from observing comets and asteroids. During the interview, Avi also referenced 2001: A Space Odyssey, another creation of Clarke's, developed in collaboration with Stanley Kubrick. The monoliths in that narrative are even more enigmatic than Rama. These perfect black rectangular prisms possess dimensions in the ratio of 1 to 4 to 9, the squares of the first three integers. They are clearly artificial and were deliberately placed on the Moon and in orbit around Jupiter. Yet their purpose remains obscure even by the film's conclusion. Are they markers, sensors, communication devices, or tests? Avi interpreted the monoliths as analogous to baby monitors, sensors positioned within humanity's developmental stage to observe our progress. He suggested they represented an advanced civilization observing our growth, noting our attainment of specific milestones, and perhaps deciding whether we are worthy of contact or should be left to our own development. This perspective is unsettling because it suggests we are undergoing an appraisal. It implies our actions are being measured against standards that elude our comprehension and are beyond our influence. If Three-Eyed Atlas functions as a reconnaissance vessel, its purpose being observation rather than exploration, then the analogy of a baby monitor becomes disturbingly plausible. Our civilization is young. We possess only a few thousand years of documented history, a few hundred years of scientific endeavor, and a mere handful of decades dedicated to space exploration. In the grand cosmic timeline, we are but infants. It's conceivable that Three-Eyed Atlas is conducting a periodic check-in, gathering information, assessing our developmental trajectory, without any intention of intervening or assisting, simply observing. This notion troubles individuals more than the idea of incidental exploration. Random exploration is devoid of personal significance. A probe might happen to traverse our vicinity, collecting data on celestial attributes and planetary composition before continuing its voyage. Such an event is inconsequential. It does not challenge our perception of self-determination. However, surveillance implies deliberate intent. It signifies that our activities are of interest, that our deeds have repercussions extending beyond our immediate surroundings, and that we are not as isolated as we had presumed. Arthur C. Clarke astutely grasped this psychological aspect. Rama's detachment from humanity borders on insult. Those aboard discover marvels, yet none of these marvels acknowledge their presence. The vessel is inert, inactive, following its predetermined path without regard for the inquisitive humans exploring its interior. Nevertheless, when Rama accelerates and departs, executing a maneuver that unequivocally demonstrates intent, the humans recognize their lack of control. They were merely passengers, incidental observers irrelevant to Rama's ultimate objective. Three-Eyed Atlas has exhibited this same indifference. It entered our solar system adhering to its trajectory. It displayed unusual characteristics, but offered no clarification. It approaches its closest point to the Sun today, passing near it, and will commence its outward journey without pausing to address our inquiries. We can observe it, measure it, theorize about it, but it remains unconcerned. It pursues its own logic, fulfills its own purpose, and we are merely spectators. The brilliance of Clarke's writing lies in his portrayal of the alien as genuinely alien, neither hostile nor benevolent, but simply beyond our capacity to understand. Rama is not a weapon, it does not attack, yet it is not a gift either. It does not share knowledge or offer aid. It exists on a different plane of concern, pursuing objectives we cannot grasp with resources we cannot imagine. Reading Rendezvous with Rama, subsequent to learning about Three-Eyed Atlas, reveals uncanny resemblances. Clarke recounts how astronomers initially categorize Rama as an asteroid, only to discover discrepancies. The reflectivity is anomalous, the form is unusual, and its rotation is unnervingly precise. Gradually, reluctantly, they concede that they are observing something artificial, and this realization alters everything. This shift occurs not because Rama exhibits any threatening behavior, but because its very existence confirms that humanity is not solitary and was not the first to achieve such advancement. Joe inquired of Avi whether encountering something akin to Rama would inspire dread or excitement. Avi's response was telling. He stated, "Finding a companion can improve your future. Discovering an extraterrestrial companion, even more so." This is not the reaction of someone apprehensive about an invasion or an existential threat. It is the response of an individual who understands that intelligence, wherever it originates, provides solutions. And if we can glean insights from alien intelligence, if we can study their methods for overcoming the challenges of interstellar travel and long-term survival, we might accelerate our own development by centuries. However, this optimistic outlook hinges on alien cooperation. Rama did not cooperate. It did not disclose its knowledge to human explorers. It remained enigmatic, inscrutable, serving only as confirmation that such possibilities exist. If Three-Eyed Atlas is our Rama, and it traverses our space without revealing its secrets, we gain the knowledge that we are not alone, but forfeit the chance to learn from their technology. We are left with the frustrating realization that answers exist, but remain inaccessible. Clarke penned sequels to Rama. In these later installments, humanity encounters Rama again and gradually begins to comprehend its purpose. It is a probe, but one that does more than just collect data. It is collecting specimens, sampling life forms from various worlds, preserving them within a vast cosmic repository. The implications are staggering. Intelligence as a horticulturalist, advanced civilizations as guardians of biological diversity, life viewed not as a product of chance chemistry, but as a cultivated resource. I am not suggesting that Three-Eyed Atlas is literally gathering specimens. However, the concept that probes may have purposes extending beyond mere exploration, that they might be enacting long-term strategies beyond our comprehension, resonates profoundly. When one dispatches a probe across interstellar distances, it is not an undertaking performed casually. It is done with intention, with defined objectives, and with a mission profile that aligns with one's values and capabilities. What might these objectives entail? Charting the distribution of life, evaluating technological progress, searching for vital resources, testing the capacity of nascent civilizations to detect extraterrestrial artifacts, issuing warnings of impending perils, disseminating genetic material to seed new worlds. The possibilities are boundless, and none necessitate communication with us. None require the probe to be anything other than what Three-Eyed Atlas appears to be, an object in transit, exhibiting peculiar yet purposeful behavior, observable but inexplicable. Clarke's vision of initial contact as passive detection rather than active interaction might be precisely accurate. Perhaps we will never witness a landing, engage in a dialogue, or receive transmitted wisdom or warnings. We might simply observe probes passing through, year after decade, century after century, each one subtly different, each revealing a fraction more about the civilizations that dispatched them. And gradually, incrementally, we will reconstruct the reality of the galaxy we inhabit. This narrative diverges significantly from the one presented by Hollywood. There is no dramatic confrontation, no existential crisis, merely the slow accumulation of evidence suggesting we are part of something grander, that the universe is populated, that intelligence is sufficiently prevalent for interstellar probes to routinely visit stellar systems. It is our fortune to live in an era where our technology has finally advanced to a point where we can detect them. Avi is essentially advocating that we approach Three-Eyed Atlas with the same mindset as Clarke's characters approached Rama, with wonder, with curiosity, and with the understanding that we may not have all our questions answered, but that the questions themselves hold intrinsic value. Rama compelled humanity to re-examine its assumptions about cosmic solitude. Three-Eyed Atlas is currently doing the same. Regardless of whether the scientific community embraces this challenge or continues to dismiss anomalies, the object itself remains tangible evidence, data, reality. Clarke penned Rama in the 1970s during the Apollo era, a time when humanity was beginning its significant outward expansion from Earth. He contemplated what we might encounter in that vast expanse and what surprises awaited us. Now, 50 years later, something akin to Rama has appeared. It is less dramatic, not as easily accessible for exploration, yet it conveys the same fundamental message. You are not alone. You are not the first. The universe is older and more enigmatic than you imagined, and the sooner you accept this reality, the sooner you can begin to comprehend its implications. Three-Eyed Atlas will depart. It will continue its journey into the outer reaches of our solar system and eventually back into interstellar space. Within a few years, it will become too faint to observe, too remote for study, and we will be left with our collected data, our speculations, and our unanswered questions. Much like the crew of Clarke's starship observing Rama accelerate away, we will ponder what we overlooked, what we failed to comprehend, what opportunities we let slip through our grasp due to excessive caution, unwarranted fear, or an unwavering adherence to comfortable narratives. Clarke possessed a profound understanding of discovery. The most significant revelations are frequently those that generate more questions than they resolve. Rama does not elucidate the universe, it intensifies the mystery. It confirms the existence of intelligences pursuing unfathomable objectives with unimaginable resources. And that confirmation, that simple proof of existence, transforms everything. Even if we learn nothing further, even if every subsequent observation merely reinforces our lack of understanding, the proof itself is sufficient. Three-Eyed Atlas is our proof, our Rama, our monolith resting within our telescopes, reflecting sunlight, shedding nickel, defying explanation. Arthur C. Clarke would have been captivated. He would have championed its investigation. He would have reminded us that science fiction is not about predicting the future, but about preparing our minds for possibilities we have not yet encountered. And occasionally, very occasionally, the future materializes in a manner strikingly similar to the predicted narrative. The baby monitor hypothesis. Are we under observation? There is an inherent disquietude in the notion that we are being watched, not attacked or contacted, but simply observed, monitored, and recorded. Akin to specimens in a laboratory, subjects in an experiment, or children playing in a nursery while unseen adults observe from an adjacent room. This is the implication derived from Avi's baby monitor interpretation of Clarke's monoliths. And if we apply this same framework to Three-Eyed Atlas, the ramifications become even more disturbing. Avi articulated this during the interview with elegant simplicity. He remarked, "Consider humanity as an infant, merely a few million years old in evolutionary terms, a few thousand years old as a civilization. We are young, inexperienced, and developing. And if there are older civilizations out there, civilizations billions of years more advanced, they might have deployed sensors to monitor emerging intelligence, not to interfere or guide, but simply to observe, to ascertain our trajectory, and to determine if we warrant their attention." The monolith on the Moon in 2001 perfectly embodies this concept, deliberately concealed, awaiting discovery. When humans achieve spaceflight, land on the Moon, and commence exploration, they activate the monolith. It transmits a signal to Jupiter, alerting whoever placed it that humanity has reached a certain threshold. We have progressed from rudimentary tools to space exploration capabilities. We are now of interest. We merit further observation. But here lies the chilling aspect. Further observation does not equate to contact. The humans who discover the monolith do not receive a welcoming message, instructions, or explanations. They simply trigger the alert and are then left to decipher its meaning independently. The true test is not whether you can locate the monolith. The test is your subsequent actions. Do you investigate? Do you disregard it? Do you attempt to weaponize it? Do you strive to comprehend it? Or do you perceive it as a threat? Three-eyed Atlas could be fulfilling precisely this function, not concealed on the Moon, but traversing our solar system at a time when we finally possess instruments capable of detecting interstellar objects. The anti-tail, the nickel emissions, the spherical form, all the anomalies we have discussed, perhaps they are not malfunctions or random occurrences. Perhaps they are deliberate signals, intentional deviations from natural behavior designed to capture the attention of any civilization sufficiently advanced to notice. Consider the implications. An intelligence assessment. Are you capable of detecting anomalies? Can you differentiate between artificial and natural phenomena? Can you overcome your institutional biases and theoretical preferences to acknowledge what you are witnessing? And more crucially, what do you do with this knowledge? Do you undertake serious investigation? Do you allocate resources? Do you treat this as a potential first contact scenario, or do you dismiss it, disparage those who propose it, and continue to pretend you are alone in the universe? If Three-Eyed Atlas is a baby monitor, we are failing the examination. We detected it, which is commendable. We identified some anomalies, also commendable. However, our response has been characterized by dismissal, rationalization, and institutional resistance to investigation. We are behaving like a child who finds something peculiar in the backyard, shows it to the adults, and is instructed to cease fabricating stories and resume playing. We are not rising to the challenge. We are retreating into comfort. Joe pressed Avi on this concept, inquiring about what the watchers would be seeking. Avi suggested developmental benchmarks. When does a civilization achieve spaceflight? When do they develop radio communication? When do they begin detecting exoplanets? When do they notice interstellar visitors? Each milestone signifies capability and curiosity, and perhaps at specific thresholds, the monitoring intensifies. It is conceivable that Three-Eyed Atlas is not the first probe to visit us. Perhaps there have been others that we were simply unable to detect previously. And now that we possess the capability to detect them, now that we have surpassed that threshold, the dynamics have shifted. This raises a question that few are willing to confront. For how long have we been under observation? Did probes visit during the Roman Empire, during the Bronze Age, during the Ice Age, when humans were scattered hunter-gatherer tribes? Were they observing us when we first mastered fire, first developed agriculture, first constructed cities? And if so, what were they recording? What data were they transmitting back to their creators? The contemplation is profoundly humbling. Everything humanity has accomplished, every conflict we have waged, every empire we have built, every scientific discovery we have made, perhaps it has all been observed, documented, analyzed, and compared to other nascent civilizations on distant worlds. And we remained oblivious. We proceeded with our lives, believing ourselves to be alone, convinced that our struggles and triumphs held significance only for us, all the while being watched. However, another possibility exists, one that Avi alluded to. Perhaps the observation is benign. Perhaps advanced civilizations have learned that intervention often proves detrimental. One cannot force development. One cannot accelerate a species through its adolescence. They must experience their own errors, learn their own lessons, and evolve at their own pace. Consequently, the monitors simply observe. They neither assist nor hinder. They record. And perhaps, if we successfully navigate enough tests, if we prove ourselves worthy, then contact will occur. Genuine contact, dialogue, an exchange of knowledge. This would position Three-Eyed Atlas as a transitional marker, the test that determines whether humanity is prepared for the subsequent phase. And at this moment, we are faltering. We demonstrate a preference for comfort over truth, for consensus over investigation, for institutional authority over empirical observation. We are exhibiting precisely the kind of closed-mindedness that might concern an advanced civilization assessing our worthiness for engagement. The baby monitor hypothesis also accounts for the absence of communication. Parents do not explain themselves to infants. They observe. They respond when the infant cries or requires something. However, they do not engage in discussions about their parenting philosophy or their long-term aspirations for the child's development. The infant would lack the capacity to comprehend. The infant lacks the cognitive framework to process such information. And perhaps this is how advanced civilizations perceive us, not as equals prepared for dialogue, but as children who must first mature. This interpretation avoids both the naive optimism of anticipating extraterrestrial salvation and the paranoid pessimism of expecting annihilation. It proposes a middle path: observation without interference, monitoring without direct contact, allowing us to develop organically while keeping track of our progress. Only when we attain sufficient maturity, only when we demonstrate the capability to handle the implications, will communication become feasible. But maturity necessitates certain qualities: humility, curiosity, courage, the ability to challenge one's own assumptions, and the willingness to follow evidence even when it leads to uncomfortable conclusions. By these metrics, our current reaction to Three-Eyed Atlas suggests a lack of maturity. We are defensive, insecure, overly attached to our existing theories, and excessively fearful of paradigm shifts. Avi mentioned during the interview that intelligence agencies recognize the importance of surveillance. They monitor potential threats, evolving situations, and anything that could impact national security. And they take anomalies seriously, because anomalies often signify something significant: a change in behavior, a new capability, an emerging threat or opportunity. They do not have the luxury of disregarding data simply because it contradicts their preferred narrative. If advanced civilizations operate under similar principles, if they deploy probes throughout the galaxy to monitor developing intelligence, then their methodology would mirror that of intelligence agencies: silent observation, data collection, anomaly detection, and the triggering of alerts when something noteworthy occurs, such as a species acquiring the ability to detect interstellar objects, or a species standing on the precipice of becoming truly spacefaring. That precipice is precisely where we find ourselves now. The past decade has witnessed an explosive enhancement in our capacity to detect and characterize objects beyond our solar system. We discovered Oumuamua, We discovered Borisov. We discovered Three-Eyed Atlas. This is not mere coincidence. It is a testament to improved capabilities. Our instruments have become more sophisticated. Our observational networks have expanded. We have actively begun to search. And now we are finding things, strange things, anomalous things, things that do not align with our established models. The baby monitor hypothesis posits that this was an inevitable outcome. Once you develop sufficient technology, you inevitably begin to detect the monitors. They were always present. You simply lacked the means to detect them previously. And now that you can, now that your instruments register their presence, the critical question becomes what you do with that information. Do you acknowledge it, investigate it, or do you maintain the pretense of cosmic solitude? Joe inquired whether this monitoring might serve a more sinister purpose. Perhaps the watchers are not benevolent guardians. Perhaps they are akin to zookeepers or farmers. Perhaps we are livestock being fattened for eventual harvest, resources being cultivated for exploitation, or a nature preserve being maintained for some inscrutable alien objective. Avi acknowledged these possibilities but did not dwell on them. His focus remained on the scientific opportunity. Regardless of their intentions, the presence of these probes presents us with an opportunity to learn. We can study their technology, reverse engineer their capabilities, and accelerate our own development. However, this optimism is contingent upon access. If the probes merely pass through, remaining sealed and silent like Rama, we gain knowledge of their existence but not of their construction. We know that other intelligences exist, but cannot learn from them directly. We are left to infer their capabilities from external observations, much like attempting to understand a car's mechanics by watching it speed past on the highway. Some understanding can be gained, but not complete knowledge, not enough. The baby monitor hypothesis is frustrating because it implies a power imbalance that we are unable to alter. They observe us. We cannot observe them in return. They are aware of us. We are barely cognizant of their existence. They make decisions regarding whether and when to initiate contact with us. We have no agency in this matter. It is profoundly asymmetrical, and humans are disinclined to accept asymmetry. We prefer to believe that we control our destinies, that our choices hold consequence, that we are active participants rather than passive objects. However, perhaps this is an integral part of the test. Can we adapt to this asymmetry? Can we accept the existence of intelligences far superior to our own, operating on timescales and with resources that we cannot match, pursuing objectives we cannot comprehend? Can we sustain our curiosity and drive despite the knowledge that we occupy a subordinate position in the cosmic hierarchy? Or will we retreat into denial, persist in the illusion of our cosmic significance, and maintain our comfortable yet ultimately false narratives? Three-Eyed Atlas is forcing this very question upon us. Its anomalies are too numerous to dismiss, and its presence is too palpable to ignore. And if this is indeed a system for observing our reactions to the discovery of extraterrestrial objects, then our present conduct is frankly pathetic. We are behaving like children who stumble upon a sophisticated device and decide to conceal it rather than inquire about its purpose. The entities responsible for this monitor, assuming they exist, must surely be disillusioned. Or perhaps this is precisely what they anticipated. Conceivably, this is a recognized stage in the evolution of nascent civilizations, the phase where they can detect surveillance but lack the maturity to grasp the implications of such detection. It is the stage where established procedures and resistance to change overpower individual insight, where the dread of a paradigm shift stifles genuine inquiry. And perhaps another stage is on the horizon, the stage where a sufficient accumulation of anomalies renders denial untenable. It is the stage where the evidence becomes so overwhelming that even the most rigid institutions must concede its reality. It is the stage where we collectively accept the premise of being observed and begin to contemplate what this means for our collective future. Today, at perihelion 3I, the object designated Atlas reaches its closest point. This baby monitor, if that is its function, is now within an optimal range for observation. We should be meticulously collecting every scrap of data available. We ought to be treating this moment as the potential civilizational watershed it represents. Instead, the majority of humanity remains oblivious to these developments. Many scientists are deliberately overlooking it, and those who do acknowledge it are largely attempting to dismiss it as something mundane. The monitor continues its watch, recording our response and transmitting data across the vastness of space to its creators. And the information we are providing suggests a fundamental lack of readiness on our part, an absence of maturity, curiosity, and bravery. We discovered the sensor in our nursery, and rather than investigate its origin and purpose, we retreated to our diversions. The experiment persists, and we are demonstrably failing. The solitary physicist and the dating site solution, a new perspective on Fermi's paradox. Envision Los Alamos in the year 1950. The Manhattan Project has concluded, and the war is over. Yet the scientists remain engaged in the pursuit of nuclear physics, in the development of weaponry, and in unraveling the fundamental forces governing atomic behavior. During a midday meal, Enrico Fermi, alongside Edward Teller and other colleagues, engages in a discussion on a topic that appears strikingly trivial when juxtaposed with their weighty endeavors. Extraterrestrials, little green men, flying saucers. As physicists, they concur that the existence of aliens is highly probable. The universe is immense, stars are ubiquitous, and consequently, planets must be equally abundant. Life on Earth arose from chemical processes, and chemistry is a universal constant. Therefore, life beyond Earth seems not only likely, but potentially commonplace. If life is common, then intelligence might arise on multiple occasions. All these points are logical and well-founded. It is then that Fermi poses his renowned question, where is everybody? If they exist, if they are prevalent, why have we encountered no evidence of them? Why no discernible radio transmissions? Why no overt constructions? Why no visits? The galaxy is ancient enough that even vessels traveling at leisurely speeds could have traversed its entirety multiple times. The statistical probabilities suggest we should be inundated with evidence of alien civilizations. Yet we perceive nothing. Only silence, emptiness, leaving us alone on this small planet, pondering our solitude. Fermi's response to this perplexing quandary is remarkably insightful. He reportedly told Joe, "Imagine I were seated next to Enrico at that lunch gathering. I would place my hand on his shoulder and say, 'Enrico, this is a question that every solitary individual contemplates.' And to a lonely person, one offers this advice. Do not be so presumptuous. You are not exceptionally appealing. They will not seek you out. You must endeavor to find them. You need to engage with dating platforms. You must peer through your window and actively search for them." The analogy is brilliant because it fundamentally reframes the entire paradox. Fermi operated under a passive assumption. Aliens exist, therefore they should naturally present themselves to us. But on what grounds should they? Why should they concern themselves with our existence? Why should they expend resources visiting every arbitrary planet harboring primitive life? We do not visit every anthill we encounter. We do not initiate contact with every crow we observe, despite crows demonstrating intelligent tool usage. We acknowledge their presence and proceed, unless a specific impetus for interaction arises. It is plausible that advanced civilizations operate in a similar fashion. They may be aware of our presence and perhaps even monitor us. However, they may perceive no compelling reason for direct engagement. We may simply not be sufficiently interesting, advanced enough, or relevant to their overarching concerns. Consequently, they do not materialize for lunch in Los Alamos merely because Enrico Fermi expresses a desire for it. They continue their own pursuits, driven by their own objectives, allowing us to develop at our own pace. However, the deeper wisdom within Joe's response lies in the concept of agency. Fermi's question is inherently passive. It presumes that aliens will act while we remain quiescent. Joe's answer, conversely, is active. We must take action. We must initiate the search. We must construct sophisticated telescopes, scan the heavens, investigate anomalies, and meticulously follow up on peculiar observations. We should be the active seekers, not the passive recipients of attention, because waiting yields no progress. Active seeking, however, holds the potential for discovery. This is precisely the approach that Avi has consistently employed. With Oumuamua, he did not merely observe and classify it. He undertook a thorough investigation. He challenged established assumptions, proposed the hypothesis of artificial origin, and rigorously pursued the evidence wherever it led. With the 3 Atlas object, he is replicating this same methodology. He is not passively awaiting the object to reveal its nature, nor is he assuming it will conform to our preconceived notions. Instead, he is actively investigating, earnestly seeking truth rather than the solace of comfort. Joe found this reframing highly valuable. He chuckled at the dating site metaphor, yet recognized the profound seriousness underlying the humor. Fermi's paradox, in reality, is not truly a paradox. It is a deficiency of imagination coupled with unrealistic expectations. We anticipate extraterrestrials behaving like characters in cinematic portrayals, appearing dramatically, making their presence obvious, and demonstrating a specific concern for humanity. However, genuine intelligence, having evolved under vastly different circumstances and driven by disparate priorities, may bear little resemblance to such expectations. Such entities might be reticent, deliberate, and patient, operating on temporal scales that render human history a mere ephemeral flicker. From their vantage point, we are the recent arrivals, the boisterous neighbors who immediately commence lamenting the lack of welcoming visits. It is entirely possible that they are observing us from their own domiciles, deliberating whether we are worthy of interaction, and awaiting signs of our maturation into engaging conversationalists rather than remaining noisy and self-absorbed. The dating site analogy extends far beyond what Avi explicitly articulated. On dating platforms, individuals curate a profile, presenting their interests, values, and personality. Subsequently, they browse through other profiles, seeking compatibility. One does not anticipate every individual to initiate contact, nor does one assume universal attractiveness. It is understood to be a reciprocal endeavor demanding effort from both parties. Humanity is currently in the process of constructing its own profile. Through our radio transmissions, our space probes, the composition of our atmosphere, and our pervasive light pollution, we are broadcasting information about ourselves to any potential observers. The 3 Atlas object might well be a component of this browsing process, a probe dispatched to scrutinize us, to gather detailed intelligence, and to ascertain whether we possess sufficient intrigue for more substantial engagement. However, akin to dating sites, mere browsing does not necessitate immediate contact. One can examine profiles without initiating a message, gather information without committing to interaction. This conceptual framework effectively explains the pervasive silence without recourse to pessimistic hypotheses such as the dark forest theory. This hypothesis posits that civilizations maintain silence because the universe is inherently perilous, because self-disclosure invites annihilation, and because predatory entities lurk in the shadows, awaiting any signals. Conversely, the universe might not be a hostile, dark forest. It could simply be a conventional neighborhood where individuals respect privacy and mind their own affairs, where intrusion upon others occurs only for justifiable reasons. Viewed from this perspective, Fermi's question becomes rather absurd. It is akin to relocating to a new community and immediately expressing indignation that no one has come to your doorstep to offer a formal welcome. Perhaps they are preoccupied. Perhaps they observed your arrival but chose not to intrude. Perhaps they are waiting for you to acclimate before initiating introductions. It is conceivable they are observing your behavior to ascertain whether you are the type of neighbor they wish to associate with. Avi pointed out that Fermi was an experimental physicist, and a highly competent one at that. Yet, when confronted with the question of extraterrestrial intelligence, he did not proceed to design instruments for evidence collection. He merely posed the question during a luncheon engagement and left it at that. An experimentalist grappling with the question of universal presence should have immediately commenced the design of telescopes for observation. They should have proposed systematic search methodologies and allocated resources for investigation, yet this did not transpire. He simply expressed his curiosity and moved on. This mirrors the pattern observed today concerning the object designated 38L. Scientists articulate their curiosity, publish scholarly articles, and convene conferences, but they fail to commit substantial resources. They do not construct dedicated observational apparatus, nor do they organize coordinated surveillance campaigns. It is treated as an intriguing puzzle rather than a potentially civilization-defining discovery. This represents curiosity devoid of commitment, questions lacking genuine pursuit. Avi's approach, however, is distinct. He has committed himself, founding the Galileo project specifically to seek out technological signatures. He is investing resources that align with his convictions. He is not merely posing the question of universal presence, he is actively constructing the tools to find the answer. He is engaging with the cosmic dating site and actively browsing rather than remaining isolated and wondering why no one contacts him. Joe directly inquired about the dark forest hypothesis, and Avi acknowledged it as a potential resolution to the paradox, positing that civilizations remain concealed due to the inherent dangers of visibility. However, his demeanor suggested skepticism. The dark forest theory necessitates the assumption that the universe operates on a zero-sum principle, where resources are so scarce that conflict is inevitable, and where cooperation never emerges as a sustainable strategy. These assumptions may indeed be flawed. Evolutionary processes on Earth have fostered both competition and cooperation. Intelligence inherently requires social interaction, which in turn depends on a degree of trust and mutual benefit. It is conceivable that these principles extend to galactic civilizations as well. Alternatively, the silence might simply stem from indifference, not hostility or fear, but a mere lack of interest. Advanced civilizations might be so engrossed in their own concerns, their own projects, and their own internal development that they have no capacity for monitoring primitive species like ourselves. They are not hiding in a dark forest. They are simply occupied with matters beyond our comprehension. Occasionally, they might dispatch probes to observe developing worlds, but these probes are automated and require minimal effort, akin to deploying a webcam in a nursery rather than engaging a full-time caregiver. The 3 Atlas object could very well be such a webcam, inexpensive, disposable, sent to our solar system alongside millions of others dispatched to countless other star systems. Not because we are unique, but because we are catalogued, identified as a world with potential intelligence, warranting periodic observation, but not demanding focused attention until we exhibit behavior that triggers more intensive monitoring. This, in fact, represents the most humbling possibility. Not that we are alone, nor that we are rare and precious, but that we are commonplace and unremarkable. We are simply one among countless young civilizations at a developmental stage comparable to our own, interesting enough to warrant observation, but not sufficiently compelling for direct contact. The probes traversing our system are likely engaged in routine checks, marking off boxes on an extensive cosmic database, assessing whether we have continued to develop or have succumbed to self-destruction. From this perspective, Fermi's question betrays a profound level of narcissism. The query, "Where is everybody?" implicitly assumes that everyone should be concerned with us. But why should they be? What actions have we taken that warrant such attention? We have mastered fire, developed written language, harnessed atomic energy, and journeyed to the moon. These achievements are undoubtedly impressive by our standards, but perhaps by galactic benchmarks, they represent mere expected milestones, accomplishments that any civilization achieves if it manages to persist for a sufficient duration. Nothing extraordinary, nothing that would compel advanced extraterrestrial beings to abandon all else and embark on a visit. Consequently, we await their concern while they await our development into something interesting. This period of waiting could extend for millennia, millions of years, or even indefinitely if we stagnate or self-destruct. The sole avenue for breaking this cycle of anticipation is through active pursuit, constructing sophisticated instruments, investigating anomalies, and following the evidence, even when it challenges comforting narratives. We must cease expecting external entities to alleviate our sense of solitude and instead endeavor to resolve it ourselves. Avi concluded this segment of the discussion by underscoring the inherently romantic nature of Fermi's question. The query, "Where is everybody?" is not truly about extraterrestrials. It is a reflection of human loneliness, our intrinsic need for connection, and the fundamental question of whether we hold significance, whether others share this peculiar experience of consciousness and curiosity. This sentiment in itself is profoundly beautiful. However, romance necessitates action. One does not discover love by remaining at home, passively hoping for a visitor to knock on the door. One must venture out, actively search, risk rejection, and expose oneself. Humanity is finally beginning to adopt this proactive stance. We are developing more advanced telescopes, detecting interstellar objects, and meticulously analyzing their characteristics. We are no longer merely asking where everyone else is. We are actively looking. And when we observe with genuine scrutiny, devoid of preconceptions, and investigate anomalies with intellectual honesty, we may discover that they have been present all along, passing through, observing and waiting for us to acknowledge their presence, waiting for us to mature sufficiently to pose the pertinent inquiries. The 3 Atlas object could represent our inaugural authentic response to Fermi's question. Not a radio transmission, not a formal message, but simply a transient probe exhibiting anomalies indicative of an artificial origin, thereby affording us the opportunity to recognize it for what it is. Whether we recognize it, whether we engage in serious investigation, and whether we overcome our institutional resistance and theoretical biases will determine our readiness for the subsequent phase, our preparedness to transition from a state of isolation to becoming an integral part of the cosmic community. The dating site is now accessible and the profiles are visible. We simply require the courage to look and the humility to accept that perhaps, just perhaps, we are not the most desirable option available. However, this does not preclude the possibility of eventual contact. It simply signifies that we must first focus on self-improvement, becoming more intriguing, more mature, and more worthy of interaction. In the interim, we will continue to search, to investigate, and to follow the evidence. For this is the behavior of engaging civilizations. They do not passively await outcomes, they actively explore. And occasionally, if they are fortunate and persistent, they discover precisely what they are seeking: negative mass, time machines, and technologies beyond our current comprehension, leading to an unbounded future. Near the conclusion of the conversation, after addressing all the anomalies and controversies surrounding the 3 Atlas object, Avi shifted the focus. He began to discuss technologies that are currently beyond our grasp, technologies we have only just begun to theorize, technologies that might appear impossible but remain theoretically permissible within the framework of fundamental physics. It was at this juncture that the discussion transitioned into truly speculative, mind-bending territory, becoming acutely relevant to deciphering the potential nature of the 3 Atlas object. He brought up the concept of negative mass, distinct from antimatter, which annihilates ordinary matter in a release of energy. Negative mass refers to matter exhibiting negative gravitational properties, matter that, instead of attracting other matter, actively repels it. If such a substance could exist, be synthesized, discovered, or somehow harnessed, the implications would be profound. Negative mass could provide a means of propulsion entirely independent of conventional fuel sources. Repulsive gravity would enable pushing against the very fabric of space, achieving acceleration without expending reaction mass, and thus traversing interstellar distances without the encumbrance of prohibitively large fuel reservoirs. Avi mentioned that he is currently collaborating with colleagues at Applied Physics on a research paper concerning this subject. This is not mere science fiction or idle speculation. It is a serious theoretical investigation into the feasibility of negative mass propulsion within the confines of established physics. The preliminary findings suggest it might be possible, not definitively so, and certainly not with current technological capabilities, but potentially under specific conditions, utilizing certain materials or field configurations that have yet to be discovered but might exist. Consider the implications for the 3 Atlas object. If an advanced civilization has successfully mastered negative mass technology, enabling them to generate or manipulate materials with repulsive gravitational properties, they could construct probes capable of efficient interstellar travel. Such probes would be free from the necessity of massive fuel tanks or enormous solar sails, relying instead on a generator producing negative mass fields to propel themselves against the space-time continuum, achieving both acceleration and deceleration at will. The phenomenon of an anti-tail suddenly becomes more comprehensible, not as a violation of physical laws, but as a sophisticated utilization of physics we do not yet fully grasp. We understand that radiation pressure exerts force, pushing particles away from light sources. This principle is applied in theories concerning solar sails and the behavior of comet tails. However, what if this effect could be reversed? What if negative mass allowed for the creation of attractive radiation pressure, drawing material towards a light source rather than repelling it? In such a scenario, an anti-tail would cease to be mysterious and instead become an expected outcome, a testament to engineered technology rather than a natural anomaly. Joe found this prospect utterly fascinating. He inquired about the possibility of time travel, and Avi confirmed that negative mass could potentially facilitate the formation of closed time-like curves, effectively enabling time machines. These would not resemble the dramatic, visually spectacular devices depicted in popular cinema, but rather genuine manipulations of space-time geometry, warping space in a manner that permits journeys into one's own past. The mathematical underpinnings are sound, and general relativity permits such possibilities. The primary requirement is the existence of exotic matter with negative energy density, which may be synonymous with negative mass. It is important to note that time travel introduces numerous paradoxes, such as the grandfather paradox. If one were to travel back in time and eliminate their grandfather, they would cease to exist, thereby precluding their own journey. This leads to an infinite loop. However, physicists have proposed resolutions to these paradoxes. The Novikov self-consistency principle, for instance, posits that any action taken in the past was always an integral part of history and cannot be altered because it has already occurred. Closed time-like curves, under this principle, become deterministic, eliminating paradoxes and instead presenting a complex causal chain. Nevertheless, even without definitively resolving all paradoxes, the theoretical potential for time travel using negative mass compels us to broaden our understanding of what the three-atlas object might represent. It is conceivable that it is not merely engaged in spatial travel, but also temporal displacement. Perhaps it originated from our future, sent back by humanity, our descendants, or whatever form our evolution may take. It might be observing the progression of our civilization from multiple temporal viewpoints, gathering data on critical junctures in our history. While this concept may sound extraordinary, it is not fundamentally prohibited by physics. And if we are seriously contemplating the possibility of artificial origins for the three-atlas object, if we are genuinely considering it as a piece of technology, we cannot restrict our thinking to only those technologies we currently comprehend. We must entertain the possibility of technologies that are theoretically achievable but have not yet been developed. These are technologies that would appear magical to us, but are merely advanced engineering for their creators. Arthur C. Clarke famously stated, "Any sufficiently advanced technology is indistinguishable from magic." This is the conceptual framework we must adopt when examining the three-atlas object, not focusing on what appears magical or impossible, but rather asking whether it is genuinely impossible according to fundamental physics or simply beyond our present capabilities. The anti-tail, for example, appears impossible only if we assume standard radiation pressure and conventional matter. However, if we allow for the possibility of negative mass, field manipulation, or technologies we have not yet conceived, it becomes a plausible, albeit challenging, outcome requiring advanced understanding and engineering. The same logic applies to its spherical form, its nickel emissions, and its behavioral transitions. Each anomaly, when viewed through the lens of potential but undeveloped technologies, becomes significantly less mysterious. Avi also touched upon the concept of artificial general intelligence, or superintelligence, a form of intelligence surpassing human intellect in all respects. This advanced intelligence, he proposed, could unlock revolutionary propulsion systems, novel understandings of physics, and entirely new methods for engaging with the cosmos. Such prospects are simultaneously awe-inspiring and daunting. Inspiring, as it suggests, we may soon possess the means to comprehend phenomena that currently elude us. Dauntless, because it implies we stand on the precipice where our own creations might eclipse our capabilities. From the perspective of 3I8s, artificial intelligence holds profound relevance. Any civilization capable of constructing interstellar vessels would almost certainly have mastered sophisticated AI. Journeying across the vastness of space for millennia is not a task for biological entities. Instead, such expeditions would be undertaken by autonomous machines, intelligent automatons empowered to make independent decisions, adapt to unforeseen circumstances, perform self-repairs, and continue their mission even in the absence of communication with their point of origin. It is highly probable that 3-Atlas, if indeed it is a probe, operates under the control of an advanced AI system, continuously observing analyzing, and determining when to deploy its various functions. The manifestation of its anomalous tail behavior might have been a deliberate choice by the probe's AI. Similarly, its subsequent return to a conventional tail configuration could have been another calculated action. These were not random natural occurrences, but rather purposeful interventions by a system engineered to optimize data acquisition, or perhaps to gauge humanity's observational capacity, or even to subtly announce its presence without being overtly conspicuous. It represents an intelligence, artificial yet undeniably real, diligently executing a directive formulated billions of years ago by beings beyond our current comprehension. Joe inquired about the possibility of seeding the universe with life, and Avi confirmed this as another potential avenue opened by advanced technological capabilities. This concept, essentially panspermia, on an intentional grand scale, poses the question: if interstellar travel becomes efficient and resources are abundant, why wouldn't a civilization choose to populate barren worlds with microorganisms or genetic material? Why not disseminate biology throughout the galaxy, fostering greater biodiversity and increasing the probability of sapient life emerging? 3 Atlas could be actively engaged in this very endeavor, not merely observing but actively distributing, not just monitoring but nurturing. This line of reasoning brings us back to the Martian hypothesis. Avi mentioned during the interview that life might have originated on Mars before Earth, suggesting we could all be descendants of Martian microbes that survived ejection from their home planet and subsequent landing on Earth. However, what if this transfer was not a matter of chance? What if a probe deliberately seeded both planets? What if 3 Atlas is part of an ancient, far-reaching network of probes dispatched across the galaxy to propagate life, oversee its evolutionary trajectory, and report on which worlds ultimately give rise to intelligent species? Under this scenario, humanity's connection to Earth is far more profound than simple panspermia. We become participants in a deliberate cosmic undertaking. It's akin to cosmic agriculture, with intelligence viewed as a crop, and 3 Atlas functioning as the farmer tending to our development, assessing our readiness for a metaphorical harvest. This harvest, hopefully not literal, would likely consist of information, cultural insights, or whatever metrics advanced civilizations deem valuable in younger species. A concluded this segment of their discussion on an optimistic note, stating, "Finding an alien partner could change your future for the better." His sentiment is entirely valid. If we could glean knowledge from alien technology, if 3 Atlas or future extraterrestrial visitors could impart wisdom on concepts such as negative mass propulsion, temporal manipulation, or any of the countless advancements a billion-year-old civilization would possess, we could potentially skip millennia of developmental stages. We could resolve challenges that currently appear insurmountable, including climate change, resource depletion, and mortality, all potentially within reach with sufficiently advanced technology. However, this optimistic outlook hinges on the willingness of these extraterrestrial entities to cooperate, to deem us worthy of their instruction. Such a decision would likely be contingent upon our own conduct during first contact. Will we approach the encounter with seriousness, conduct thorough investigations, and demonstrate intellectual fortitude and inquisitiveness? Or will we resort to dismissal, rationalization, and retreat into the comforting embrace of denial? Our reaction to 3 Atlas could very well serve as the crucial test determining whether we gain access to this profound knowledge or remain isolated children playing in our cosmic nursery. The technologies we struggle to envision are of paramount importance, not because we require them immediately, but because they represent our potential future. The possibilities that emerge when one achieves longevity, avoids self-destruction, and relentlessly pursues advancement. Concepts like negative mass, time travel, and artificial superintelligence are not mere figments of imagination. They are logical extrapolations of established physics and current technological trajectories. While these require significant breakthroughs beyond our current grasp, they are not inherently impossible, merely exceedingly challenging. If these advancements are attainable for us eventually, they are undoubtedly achievable for civilizations that have had billions of years to refine them. This implies that 3 Atlas might be employing technologies so advanced and alien to our understanding that its operations appear miraculous. The anomalous tail phenomenon could be a trivial, routine application of principles they mastered eons ago. Its spherical form might represent standard engineering practice, the most logical design for any interstellar probe. The emission of nickel particles could be the result of component degradation from materials we wouldn't even recognize as technology, even if we had the opportunity to examine them closely. We are akin to ants observing a computer chip. We can perceive its presence and measure certain characteristics, but we lack the conceptual framework to comprehend its function or operation. 3. IAL is our equivalent of that computer chip. Observable, measurable, yet fundamentally beyond our present capacity for understanding. The critical question is whether we will persist as ants, content with our rudimentary colonies and oblivious to the impossible artifact in our midst, or whether we will evolve, develop new faculties, and ultimately comprehend what we are witnessing. Today, October 29th, during its perihelion, presents us with the optimal window for data collection, observation, measurement, and preparation for a future where we might grasp the meaning of these findings. That future will arrive either through our own gradual scientific and engineering progress, leading to the eventual feasibility of negative mass and time travel, or through direct interaction with the creators of 3 Atlas, from whom we can learn firsthand. However, this future is contingent upon our survival, our ability to avert self-annihilation, our sustained development, our unwavering curiosity and courage, and our refusal to allow apprehension or institutional inertia to impede our investigation of the anomalies directly before us. 30. Atlas is a harbinger from a potential future, a testament that the technologies we can scarcely conceive are not only real but attainable, awaiting our readiness to receive them. An unbounded future is not an inherent guarantee. It is an achievement earned through perseverance, intellectual integrity, a willingness to question deeply ingrained beliefs, significant investment in science, exploration, and understanding, and a recognition that when an inexplicable phenomenon manifests within our solar system, when anomalies accumulate to an undeniable degree, and when evidence strongly suggests an artificial origin, the appropriate response is not dismissal, but thorough investigation, learning, and inspiration toward our own extraordinary accomplishments. Negative mass may power 3IATL, but it is curiosity that must propel us toward answers, toward truth, and toward the boundless future that lies ahead, provided we possess the fortitude to pursue it.